Hello, everyone. I'm very glad to see you again on the second day of our conference, TMPA 2021. Yesterday, we had very interesting topics and presentations. You can watch all of them. You can find links at our Telegram chat and also YouTube channel. So, we start tomorrow. Today, I'm sorry, we start today. Um, from the topic automation in software testing, humans and complex models. And the first keynote speaker for today is Iosif Itkin, CEO and co-founder of Exactpro company. Iosif, hello.
Good morning, everyone. Thanks a lot for the introduction. Let me open the slides. Oh, thank you. Thank you very much. Hello, everyone. It is a great honor to open the second day of TMPA conference. Today, I'm planning to tell you a little bit about Exactpro, one of the organizers of software testing, machine learning, and complex process analysis conference, about areas of research that we think are important, about projects where we think additional collaboration across industry and academia might be required, and also highlight some of the important topics for our company and for our industry. Thank you. So Exactpro is a software testing business. We work with clients on all continents in 20 countries, mostly exchanges and clearinghouses. We employ over 700 specialists. We were founded on 9th of September 2009, software testing day, and we continue to work in this area. We build software to test software. We develop tools and methods applicable to mission critical financial market infrastructures. We work with exchanges and clearinghouses from Australia to Canada, from South Africa to Japan, etc. Exactpro delivers projects related to quality, availability, reliability, scalability, performance of platforms across the globe. We work with the companies like Johannesburg Stock Exchange, Airbus, Skytra on delivering their Nasdaq-based platform, with Australian Securities Exchange, and with many other organizations. Information about our project is available online in form of case studies, white papers, and research papers as well. Exactpro work received multiple awards recently for our work in operational resiliency, field for the work of Global Exchanges Department, for the new open source platform to enable the next generation of automation in software testing, TH2, and also for the work in DLT area delivered in collaboration with R3 Corridor. About me, I am CEO and co-founder of Exactpro. My main role is to develop our business and to design better ways of providing software testing to our clients, but also I'm involved in a number of industry and research initiatives. I represent Exactpro in Zero Outage Industry Standard. I work in fixed trading community most group monitoring, onboarding, and software testing. I'm proud to work in Tomsk Polytechnic University and to lead the laboratory of software testing, LOST. And also, I am one of co-founders of TMPA conference. Zero Outage Industry Standard is a cross-industry collaboration initiative that has members from leading technology providers and also large companies who operate mission critical technology. The goal of Zero Outage Industry Standard is to define best practices around four pillars: processes, platforms, people, and security to achieve better resiliency and decrease the number of outages in live service. The standard is available online, and also Zero Outage Industry Standard collaborates with a number of research organizations, including University of Vienna, to carry out research, in particular related to soft skills necessary to specialists who are working in high availability environments, so to explore what is necessary to deliver and operate very resilient platforms. MOST is one of the working groups in fixed trading community, one of the main fintech collaboration and standardization initiatives. We are trying to explore what are the best practices that are most applicable to the context of fixed trading, electronic trading, and post-trade. We are working on exploring what is currently available and what can be improved. The work group looks at various things, including machine learning, machine readable specifications such as fixed orchestra. And last but not the least is a laboratory of software testing that was recently created in Tomsk Polytechnic University. As a part of this laboratory, we are working to strengthen both research and education in the area of software testing, especially software testing for complex intelligent systems. Our first project this year was online course, software testing for complex intelligent systems and autonomous vehicles. This course was a part of autonomous driving AI test challenge, part of IEEE AI testing conference. The course is available online, both in English and Russian, and we are looking forward to develop this initiative next year. And of course, this conference, software testing, machine learning, and complex process analysis, Stanislav and I co-founded TMPA in 2013. Originally, it had a more narrow scope. It was called Tools and Methods of Program Analysis, but we later expanded, and a TMPA conference started in 2013. There was 2 editions in Kostroma, one in 2013, another in 2014. Then the conference moved to St. Petersburg. We had in 2015 a conference in St. Petersburg. In 2017, the conference moved to Moscow, 2019 in Tbilisi, and this year we have TMPA in virtual Tomsk. I hope, and probably everyone else also hope, that the next edition of TMPA will be offline, and we'll be able to meet each other and work in the same room. Proceedings of TMPA conference for the several editions are published in Springer. The conference is delivered in cooperation with ACM SIGSOFT, and of course I am very grateful to everyone who supported TMPA. First of all, the authors of the papers that were submitted for thorough peer review, to program committee who performed at least 3 reviews for every accepted paper, and of course to the organizing committee and Tomsk Polytechnic University, who made this conference possible. As a part of our work with Tomsk Polytechnic University in Laboratory of Software Testing, the key direction of our work is AI testing. AI testing stands for 2 things. One is testing AI-based systems, so systems that incorporate machine learning. And the second one is AI testing is applying machine learning and artificial intelligence to software testing. Exactpro motto is build software to test software, and we think that AI testing area of research is very important. We believe there will be substantial results in this area because software testing and systems in test environments provide a wider variety of possibilities of failure comparing to what happens in production. we hope that this research will be delivered and accepted to a number of major research conferences such as IEEE AI testing. Over the last 3 editions of AI of IEEE AI conference, our research teams were able to submit interesting research papers. There are other interesting and high-profile research conferences that I hope will also happen next year offline alongside with other things, and I hope TMPA itself will also be offline conference, and I would like to invite all researchers who currently participate in TMPA to consider a number of other conferences. There's an interesting conference in our field that is very good for those who just started. It is Sarkozy Spring Summer Colloquium for young researchers. Usually happens in May and June. And for those who have very good results and things that are worth for consideration, one of the top conferences next year will happen in South Korea, and call for papers is still open there. So software testing is a complex and nuanced field. If anyone will go into Google Scholar and search for software testing, there will be the top links will classify software testing as art, as craft, as research. So it is an interesting thing where software testing can be positioned on continuum from art to engineering. Some schools or groups claims that software testing is art. According to the recent survey during one of internal Exactpro divisions talk, it is the most popular opinion within our own team. There are books that explain that software testing is a craft. Some tool vendors or claim that their products represent engineering in software testing. But overall, it is a continuum from art to engineering, and it would be interesting to compare science and engineering part of software testing. I would like to recommend a very interesting book by Eric Drexler related to the recent developments in nanotechnology, radical abundance. And in this book, there is a detailed comparison of scientific inquiry and engineering design. So good engineering is based on the sound science, and science needs instruments produced by the engineers. But what is important between scientific and what is the main difference between scientific inquiry and engineering design is the anti-parallel flow of information. In engineering, we are trying to convert an abstract model into something useful, for example, a physical system. In scientific inquiry, we are trying to understand a physical system and build a model that describes um, describes it. So these two activities, they have different purpose and different flow of information. So what about software testing? Software testing is exploring software with the intent of finding bugs. Software testing is an empirical technical investigation conducted to provide stakeholders with information about the quality of the product or service under test. So, software testing is a research activity and similar to the difference between software testing, between scientific inquiry and engineering, the same applies to software testing and software development. Development is activity targeted on building some useful product software from specification, from design concept, uh, turning model into software. Software testing, on the other hand, is obtaining information about system under test, about object of study, and building models of the system under test. Software testing and software development have anti-parallel flow of information. The purpose of software testing is to understand the system under test, to understand technology assets that are built and operated by organizations. And in the modern world, technology represents a substantial portion of valuation capitalization inside most of organizations. And there's a famous quote from Warren Buffett: never invest in a business you cannot understand. And the best way to understand your assets, your technology, is to do a proper software testing. So software testing does not deliver quality. Instead, it can provide understanding of the systems that can be used by different stakeholders to make good and sound investment decisions related to building, transforming, and operating their technology. So, software testing, we now understand what is software testing and where it's placed. And if we'll return to the diagram, an important thing about it is that in both software testing and software development, we have models. The development is trying to turn a model into useful product, and testing is trying to turn the version of the product or service under test into the model. So models are very important to software testing. According to context-driven school, context-driven testing school of software testing, all testing is model-based testing. So for any exploration of the system, we need to have some model. Frequently, these models are implicit. It can be something in the human's head rather than a formal specification. But all software testing is model-based testing. Even if we look at some approaches that are prevalent in fintech industry, such as behavior-driven development or operational data replay, the most frequently used two approaches to implement automation in software testing. Both approaches also represent models and are based on simplified models. In particular, Gherkin scenarios, stories that describe the system's behavior represent a very simple version of models of the system under test and their behavior. Another approach also commonly used in the industry is based on assumption that the best model of a cat is another cat, or preferably the same cat, and the best model of the system under test is the same system, or ideally the previous version of the system. Most of approaches to automation in software testing are based on comparing the current version of the software using automated checks against the previous versions of the software in one form or another. So automated checking, and even this approach, it is also a model-based testing because it is based on a simple assumption that the new version should be more or less close to the old version. One area that I think is not properly explored is terminology related to manual testing and automated testing. So manual work is work that relies on humans' muscles, and it would be fair to say that we usually do not use muscles a lot when we perform software testing activities. There are three things in humans that communicate or are involved in software testing process, and like hands, eyes, and brains. And it would be fair to say that it is difficult to use term manual testing because most of the testing is not really relying on manual force. On the other hand, quite a lot of good and efficient testing relies on tools. So tools are objects used to extend the ability of individuals to modify features of the surrounding environments. And tools can expand our capacity. So if we want to support software testing activity, we need tools that will expand and extend abilities of our hands, our eyes, and our brains. And clearly, any software itself is already extension of our ability, the ability of our hands to pass signals. But in order to do proper software testing, we need tools that will extend the ability of human brain. So human brain is the main test instrument. Automation is the technology by which a process or procedure is performed with minimal human assistance, and it means that something happens in the absence of the humans. Once again, in order to deliver something in absence of the human, we need to find a substitute. To hand, it is very easy. To eyes, it is more complex but feasible. And to brains and judgment, and this is of course a question of intensive research and exploration, whether it is feasible or not. And any business automation can amplify the efficiency of efficient operation, and it can magnify the inefficiency of inefficient operation. Good software testing is based on three pillars: processes, platforms, and people. So when these three pillars represent work efficiently, when there are efficient processes, efficient platforms, and efficient people, it is possible to implement efficient automation in testing. When any of these pillars contain inefficiencies, it is very easy to amplify inefficiency of overall software testing process by trying to automate its parts. Very important field in better understanding automation in software testing is model-based testing. Using models for test case generation, prioritization, etc. So, as I mentioned, all software testing is model-based testing, but there is a more narrow definition of model-based testing. As a narrow definition, model-based testing is when more formal models, explicit formal models that can be expressed in some machine-readable, well-defined notations are used. More formal test generation and approaches are used. So we can specify algorithms to generate tests from the models, and also more formal checks are used for mechanical test execution. And as in any other field, complex models are very useful, but also present quite a lot of challenges. So when we are trying to use complex models to understand reality, we face quite a lot of challenges, to be fair. And if we look around, we will see quite a lot of models that affect our daily lives and our future, from models related to pandemics to models related to climate change. There is a very famous quote that describes the state of the models. So all models are approximations, and essentially all models are wrong. It also is true for the models used in software testing. So all models are wrong, but some models are useful. So the valid direction of research is to find models for software testing that are useful. There's an interesting work that is trying to explore the ways of assessing the reliability of complex models for physical systems. It is a report that looks at various use cases. One interesting thing there is that it explains the difference in types of probability used in the models to make predictions. For example, when we say that a particular weapon works with 90% efficiency, so with 90% efficiency, it works. With 90% of probability, it works, and with 10% of probability, it does not work. There are two very distinct cases on how it can be in reality. The first one is that every individual unit of weapon, every individual weapon might not work with the probability of 10%. So two different units, one can work and another, one might work, another might not work. It is aleatoric probability. There is another possibility when this probability 10%, our theory, the science behind our tool, behind our weapon is not correct. And then all units of our tool will either work or not be okay. So from the first perspective, these are the same probabilities, but when we start to apply it in practice, we can see substantially different results depending on these two types of probabilities. So say if we have two weapons, then the probability is that will be able to hit the target with both of them differs, and the probability that we'll be able to hit it in the first case is 81%, in the second is 90%. So it is better when we have probability to have a common cause in all weapons to fail. On the other hand, if we need to hit the target at least one, it is of course a more preferable way would be to have the first case where our weapons will fail individually. This gives us a substantially high chance of survival if we depend on the fact that at least one of the weapons is okay. So the second case is when the science is wrong. The first case is when individual unit is wrong. And in software testing, our target is to hit the defect at least one. That's why we should never build a global universal model of the system under test, because it is most likely to be wrong. Instead, we need to build a diverse variety of models that will describe the system under test. And the preferable way is to have models that are based on different assumptions and have different science behind them. So cut your problems down to sizes. The idea is also known in reliability engineering as defense in depth. So the problems happen when there is a gap in every layer. In software testing, we need to build as many layers and as many diverse models and possible to try to hit a target, to identify defects. So all models are wrong, but we need useful models, the ones that can serve as the only purpose of software testing is to find information about the system and identify defects. Simplified models have many limitations, of course. Sometimes they are over simplified, and instead of a real model, we have a cargo cult model that only represent some features of the system. So a wooden plane built from straws will not necessarily fly, but in some cases, if it is not the only model that we use, it can be useful. On the other hand, sometimes people look into complex models, for example, a huge automated regression libraries, and take their output for granted. And this results in aggregated simplified model of the system. The way to deal with it is to apply scout mindset, to look at all models with the motivation to see the things as they are and not as we wish them to be. And it is one of the main requirements to software testing. In Exactpro, quite a lot of our work is currently focused on developing microservices platform TH2 available in open source. The main idea of the platform is that it enables applying a wide variety of different models to test complex distributed systems. We are trying to build the platform in a way that it allows to have both unification and diversity within the same test harness, so we can efficiently apply a wide variety of models based on different science and assumptions to find defects in a system under test. Well, what is important for applying every model is that the facts are more important than narrative. Software testing is information service. As journalists, we should study the reality and report about it rather than push the narrative. And I think a very important field of research is how our biases and our desires affect the output of software testing. Thanks a lot. So quite a lot of Exactpro research is present on our YouTube channel and social networks. Please do subscribe, and thanks a lot. And I wish you to have a good day today of the conference with several research papers to be presented later. I will try to look at the questions now, if there are any. Thank you.
Yes, there are. Thank you very much, Iosif. Very interesting presentation and very beautiful presentation. Thank you for telling us the story of TMPA creation. We have questions. Which companies are leading in the field of outsource auto tasting around the world and in Russia?
Okay. So I think it is very important for research community to look more precisely at the terms of manual testing and automated testing. There is no such thing as manual testing because no one is really using muscle labor to do anything with software. So in every operation with software, we rely on some kind of a tool. And automation is the process where we decrease humans' involvement in the process or procedure. There are no testing activities that can be fully automated. So we need to ask ourselves what part of testing can be performed without human involvement, without human judgment. I think it makes sense for researchers to look into these terms more closely. Recently, I found that in ACM, in IEEE papers, the term context-driven testing always is absent in search results. It would be a good idea for researchers to look more. So yes.
Mm-hmm.
And what automation is not reserved for regression testing, but regression testing is to a degree a model-based testing based on a model that the new version of software is the same as the previous version of the software. It allows to both to be model-based testing in a narrow sense, in the sense that we can use the previous version to generate test oracles to do checks against the new version. As for the companies, there are many companies involved in software testing in different regions. Probably it would be inappropriate for me to comment which one is the best, but everyone knows which one.
Thank you. Yes. Next question, or many questions we have. Is there a fundamental difference between system software testing and applied industrial software, which can continuously evolve functionally?
Okay.
I can.
Can you please copy the question? Is there a fundamental difference between system software testing and industrial software? Not sure I understand the question. So most of the industrial software represents systems or systems of systems, and most of it has evolving functionality. So if the system evolves and if it presents value to somebody, it makes sense to understand it better. And software testing is the process of understanding software. I think it is applicable to every type of software, regardless of whether it evolves or not evolve. But if the software is not evolving, it probably means that it is not valuable to humans, and no information about it is really required.
Thank you. On a typical project, how much testing is automated? Is there industry statistics on it? And would you say it's reflected in the Exactpro practice as well? If not, do you automate more, less than the average amount?
I think no software testing is fully automated because exploring the world requires human judgment. But it is possible to use quite a lot of tools and automate many activities to support software testing process. Then there is the question I can see sometimes the complexity of a function is so big that the function testing is comparable in complexity to it. Exactly. So not sometimes, but most of the time, we need to build models for complex systems, and models are always based on three features. They map existing object, they reduce or simplify it, and they should also have some pragmatic value. So for complex systems, it is necessary to build models that will have reduction feature. So we will always ignore particular aspects, and in order to use these models to find issues in the software, we need to have not one model, but an ensemble of models, ideally based on diverse assumptions and approaches to prepare models. So when one model will not be able to identify the issue or help us to identify the issue, another one will.
And to follow up on that, would you say automation is mostly reserved for regression testing?
No, automation is reserved to the processes and procedures that we want to perform without humans. If we have machine readable based specification, we can use an algorithm to generate lots of scenarios. If we have a reliable test harness, we can use it to run the generated scenarios without in absence of a human. If we are able to use particular oracles to generate checks, we can apply these checks in the absence of humans. Where we do need humans is to continuously develop new models and also to interpret the results of applying these models to software testing. So it is possible to remove human from most of mechanical processes, but humans are required for any exploration to interpret the results and to improve the models. A good thing about model-based testing is that it allows us to make this distinction very specific. So we can define where humans can be absent and where they need to be present. So if we have something that is machine readable that can be used as a source for algorithms that generate tests and checks, we can split. So this is the part, mechanical part, that can be performed without humans, and this is the part related to improving our understanding and updating the models. This part, of course, require humans most of the time.
Fortunately, humans are still required.
Pretty clear.
Yeah. One more question and comment. You have subtitled methods into machine learning in the name of the conference. Don't you think that nowadays our world is just blindly following the trends and simply does not know how to build adequate models?
Well, so models are extremely important for today's world, and humanity relies more and more on complex models. As I mentioned, models of, say, pandemics. So they affect many decisions that affect our lives daily. So policy decisions are based on some mathematical models. The same goes for climate, where there are models, lots of models that are very complex and contain lots of uncertainties. The same goes for every model of complex software. So to describe something very, very complex, we most likely will use a complex models. And indeed, by relying on complex models, we as humans have multiple issues. The first one is that we can oversimplify things and then get into the cargo cult mentality, where we are looking at some straw man version of the reality, or we can blindly trust, so follow the science, whatever the model tells us, we follow it without trying to critically assess it and constantly improve on the new obtained data. So that's why I do recommend everyone to read the book by Julio, Scout Mindset. I think it is very related to software testing. I do not think software testing is ever mentioned in the book, but it is very related on how we see the things and how we interpret new information. Thank you.
Thank you. And last comment. Sometimes the complexity of a function to be tested is so big that the function for testing is comparable in complexity to it.
Yeah, I think I've covered this one. So indeed, it is possible to build the model that will be or will exceed the complexity of the system under test. And to a degree, it makes sense because a controlling system should have more degrees of freedom compared to the controlled one. But it is always a good idea to understand the reason why we are using models in testing. So they should have pragmatic value, and to have pragmatic useful value, the models should have the right degree of complexity so we can maintain them and use to identify defects. So there is a balance between oversimplified models and models that are too complex to be useful. Thank you. Thank you very much.
Thank you. Thank you. We had very interesting and fruitful discussion. So we continue. Now, let me introduce the next speaker, Julio Cesar, lecturer at Higher School of Economics. Julio. Hello. How are you?
Good morning.
Good morning.
So it's supposed that the slides should be here in the platform. Perfect. So they are loading. Thank you. So just 1 second. So well, I hope you see the slides and you hear me and see the camera. You hear me? Yes, perfect. Thank you. So good morning, everyone. So my name is Julio Carrasquel, and also Irina Lomazova, co-author of this work and head of our institution. So the Laboratory of Process-Aware Information Systems. So we are in the Higher School of Economics in Moscow. And this talk would be on how we can find deviations on trading systems using formal models, in particular Petri nets and process mining. So our application domain is on trading system, where traders submit orders into a platform to exchange securities. So we could have Ben sending an order to buy forex stocks of some security, and Sam also wants to sell such stocks of a security. So these orders go to an order book, and the platform of this system will place these orders in an order book, and it will automatically perform a matching between these two orders. Now, our focus is on how to validate that the software, that the functioning of this process, it's working as expected. So our focus is how to find and to search deviations in these components of the trading system. And for this purpose, we use conformance checking. What is conformance checking? So it's a method from process mining to check if runs of a system recorded in even logs, so we have real behavior recorded in logs. We would like to compare whether runs that we capture in these logs behave or comply as the specification of the system describes. Of course, we do not compare the logs with a documentation. We need also to abstract the requirements into a model. In our case, we use a Petrinet, and more precisely an extension of Petrinet, which is called colored Petrinets. I will introduce it soon. And then we compare the even log that has runs of the system, real behavior, with the model that specifies how should behave the system, the expected behavior. We have this conformance checking method, and finally, it should output the deviations, so a list of deviations. Each deviation will say a precise difference where the system differs from the specification. In which event? In our case, we are focusing in which order book, which order has the problem, what activity or what attributes change it incorrectly. So these are things that we are going to introduce. So I will go in the following order. First, to introduce what's the model, then how is the even log structure, and then we see how we compare both inputs, models, and the logs. So first of all, to introduce ordinary Petrinets. So Petrinets are a well-known formalism for modeling and analysis of different kinds of distributed systems. So it's a graph composed by two kinds of nodes. We have the transitions, that are the boxes. We have the places, which are the circles, and they represent local states. The transition represents the activities, and the places may store tokens, which represent control threads, resources. One important aspect here to focus is that we focus on the control flow. So the activities and their causal dependence, the causal order in between the activities. In this example, you see a Petrinet model for the workflow of an order in a system, one specific order. So, for example, when I say control flow, I mean that if an order expires, so if the activity expires, is executed, then the trade should not happen because the order was dropped from the system. Another important thing is that these models are executable. So we define the firing of a transition that removes tokens from input places and produce the tokens in output places. For example, if we execute, we fire the transition accept, and this represents the execution of accepting an order into a system, then this control thread, this token from the input place, is moved to the output place, meaning that now the order is in a state of accepted. Now, what's the problem with this ordinary model? First of all, this is just limited to study this causal order in between the activities. But of course, we know that there are other aspects that they can influence on the order. For example, the data, the stock prices, the prices. So many attributes that can influence on the behavior of the order. Also, we would like not to study just one order, but how multiple orders in an order book interact. So this is why now we go to a more complex model, so more rich. And with this example, now I'm going to introduce colored petri nets. Now we are not going to model just one order, but multiple orders in an order book using colored petri nets. What's colored petri nets? Now the idea is that the token does not represent a control thread, but now the token represents an object, and the object is from a specific class, and we call this class a color. This is why the metaphor of using colored petri nets. The places, now they are typed, indicating which is the class of objects that they contain. For example, here we have two places. On the left side, we have a place for incoming by orders, the blue ones. And we have a place for the incoming cell orders. For example, the blue token has data associated, has a tuple. And the tuple abstractly represents the order with the attributes. So we have that in place P1, there is a by order with an identifier B1 submitted in some time T1, and this order has been programmed to buy 5 stocks at a price of $22 per stock. And the same principle goes for the cell orders. So we have a tuple with identifiers and other attributes of the order. Now, also we have activities in the same way that petri nets. So initially we have the orders and they can be submitted by some traders. And places P3 and P4 represents that they arrive to the system after being processed. Also, we have activities new by order and new cell order. So this means that when the orders pass it, these activities, when they move to P5 and P6, such places represent, respectively, the buy side of the order book and the sell side of the order book. Once orders are in the order book, so in P5 or P6, now they can be crossed, they can be traded. For example, if I have one order B1 with 7 stocks in the buy side and I have a sell order in P6 that represents the sell side of the order book, so we can execute a trade between these two orders. And this means that such orders will go to the sync places because they have traded exactly the same quantity of stocks. B1 has 7 stocks, S1 has 7 stocks. Another important aspect of colored petri nets is that the output arcs allows to transform the data of the tokens. For example, I will go back. You see that both orders has 7 stocks. Is the last attribute of the tuple. Now you see that in the trade transition, in the output arcs, there are in the last component there are zeros. So this means that the stock quantity will be transformed to 0 because this means that both orders have traded exactly the number of stocks that they have. So I bought 7 and the other order is selling 7. Now, there are more variants of trading. For example, it may happen another variant of a trade where the sell order is filled, where the buy order returns with a stock reminder. So we decrement the quantity of the buy order by the number of stocks of the sell order. For example, if I have 7 stocks in the buy order, the sell order has just 1, what will happen? The sync order goes to the sync with 0, and you see that now the buy order that had 7 now has 6. And this transformation of the data, it's because of the output arc of the transition trade 2 that allows to describe how it's decremented this attribute. Finally, similarly, there is another trade where the buy order is filled and the sell order is the one that returns to the sell side of the order book. So in addition to the trades, we can have many more activities. For example, we can have this card of buy orders and sell orders. So this is an example of a colored petri net modeling the management of an order book. Of course, here we are abstracting from many other activities that may happen in the order book. But still, this could be useful for modeling some kinds of order books. For example, this could be an order book for limit orders, where the price does not change, And also the orders have no amendments. For example, the users are not editing the orders. So we have, as an example, this colored PetriNet representing the management of an order book. What about the event logs? Now, the event logs consist of cases, and each of them will be related to a run in an order book. So we have a case for order book 1, second case for order book 2, and so on. Each case has associated an ordered sequence of events. This is what we call a trace. And here I put an example of a trace for one case. So we have a series of events, and in each event, we have which activity was executed in that order book and which were the objects involved. In this case, the objects are the orders. So for example, we have that the event 1 was that 1 by order was submitted, and specifically order B1 with these attributes. So we have seen how it's a colored PetriNet model, and we have seen how it's an event log, specifically one trace. Now we will see how the method works of comparing both inputs. The idea of the method of the conformance checking is to execute the colored PetriNet as indicated by events of a specific trace. And when this is not possible, when we cannot execute the model according to the events, is that we will detect such deviations. So I will show an example, and then the kind of deviations that we can detect. So the method in this example begins as follows. We have a colored PetriNet model representing the management of an order book, a simple one. And in the left side, we have a trace. Of course, it's a small one. It's just for example, what we are going to do. In the right side, you have that the model, it's empty, so it has no tokens. We are going to populate this model with the distinct objects that were inserted. So the objects are the individual orders of the order book that were trading. So we have, in this case, we have 3 orders. We have B1, S1, and S2. We are going to insert it in dedicated sources, so where they are going to start to interact. So you see that B1 was inserted in P1, like a token, and the cell orders S1 and S2 are inserted in places P2. Once we have the model populated, so the model is a template, and it's populated with the different objects of this trace, is that now we are going for every event of the trace to execute the model as indicated by every event. For example, in E1 is saying, okay, we need to execute submit by order with order B1. Is it possible in the model? Is B1 in place P1? It is, so we can fire the transition T1 transferring such a token from P1 for P3. And this means that the model reproduces what actually happened in the real system. And then we continue. We go to another event. We can, for event E2, we can fire the transition new by order with the input object B1. It's possible. So still, the log reflects exactly what the model, what the system should do. For the other side, we have that events E3 and E4 are for transferring S1 to the order book. And actually, this is possible according to the model. So now we are in, so I want to stop in event 5. So what happens here? In event E5, it's saying the real system in that order book, we executed the activity new cell order, so an order S2 came to the order book, but S2 actually is not in place before, which is the requirement for the execution of the new cell order. The activity is in place P2. And this means that there is a control deviation because the new cell order was invoked for order S2, but actually it's skipping the causal ordering imposed in the model. So the submit cell order for S2 was not fired, did not execute in the real life. This could be an example. So this could be an example of an order that entered to the cell side of an order book, but without being verified by the system, possibly via backdoor. But what happens? We need to continue the replay. We need to continue to execute the model according to what happened in real life. We need to force. So simply what we will do is to jump this token to the place required for emulating this action. And this is what we did. So we transferred the token S2 to the input place needed, and we executed then the new cell order. Now, the last event, what happens here? So we have the order book with the following state. In the buy side, we have order B1. And in place P6, in the sell side, we have two orders, S1 and S2. The last activity is about a trade between B1 and S1. B1 has price 22 and S1 has price 21. Now, here there is what we call a rule violation, another kind of deviation. We can program the activities of the transitions in such a way that each time that we are going to fire a transition, we check if a rule is violated or not. In particular, for this case, we want to check if the priority of orders is being violated or not. In this case, there is a violation because we consider a rule where the highest ranked sell order should be the next one to trade. In this case, the highest ranked here is the one with the lowest price, should be 19. But in the event, the one that was traded first was S1 with 21. So this is what I write here. The highest ranked sell order S2 with price 19 should have traded before the sell order S1 with price 21. But in event E6, so in the real system, the order S1 traded before. And this is not okay because then a rule violation was happening. So this order precedence rule for the orders was violated. This is another kind of deviation we can detect. In any case, we continue the replay and we are going to fire the transition. The transition says that the order B1 that has 5 stocks changes to B1 with 3 stocks because it's trading with order S1 that has 2 stocks and then it's fully filled to 0. So this is actually what happens in the model. So you see that now order S1 that was in the order book, now it's to the sync place. It's because it was filled. The buy order returned to the buy side, and now the quantity was updated to 3. But here there is another deviation. In the real system, according to the event, it says that the order buy 1, the quantity of stocks after the trade was 4. But in the model, after the trade was 3. So you see here there is a difference. What we could conclude that the real system, as observed in the event, erroneously updated the stock quantity. Of course, when I say erroneously, it's because it did not make it in the same way that the model. However, we would like to replicate what in the real system is done. So this is why I'm going to force to update the quantity of stocks in the same way that the real system. And this will allow us to continue the executing the model according to the following events. But in this case, we stop it because we have all the events. The final kind of deviation that we can detect is non-proper termination. So we are modeling processes, and we would like that this process at the end has a desired final state. The desired final state would be when all the orders traded or are dropped. For example, if we consider day orders, what are day orders? The orders that should have traded at the end of the day or be canceled. So in this case, we shouldn't have orders in the middle of the process. You see that here we have B1 and S2 that remained in the order book. So this means that they were not fully processed by the system. They should have arrived to some final states. So in summary, which are the different kind of deviations that we can detect in this method? Control flow deviations. So we have activities executed by a process given some object, but we illegally skipped activities that should have been executed before. We also have rule violations. So we want to check if an object with less priority has been processed before. Resource corruption. Maybe the real system transformed attributes in a different way that the model specifies. And the last one I comment, it's about non-proper termination. What about if the objects stayed in the middle? They hang it in the middle of the process. They were not fully processed by the system. So the last part of the presentation, it's about experimental evaluation and setting. So how do we evaluate our methods? So we took a set of financial information exchange protocol messages. So these are a particular standard of messages which are exchanged between users and a trading platform. We extracted from these messages an event log where each trace relates to an order book. And we consider a special subset of these messages. As an example, we considered only order books with day limit orders where there were no amendments, no modifications of these orders. In this case, with the data we had 73 order books to study. And this means 73 traces. So we have the event log with this real data. And also we have a colored PetriNet model, which describes how should be the management in this particular subset of order books. And we have an implementation of this experiment. So from a set of financial information exchange fixed protocol messages, we came to an event log. The event log we formatted as a CSV file, where we have for each event, we have to which order book is, at which hour the activity was executed, and which were the objects involved. So the same model that I described at the beginning of the presentation is the one that actually represents this order book with limit orders, day limit orders with no amendments. And one question is about how this method was programmed and how the models are built. For this case, we used a Python programming language. There is a special library, a well-known library, which is called Snakes, which facilitates the construction and simulation of high-level PetriNets. So in short, the colored model, the colored PetriNet model, is built as a Python script. And this is an example of the deviations that we can find. For example, we have that in this trace, this number of traces, so in this order book, in this event, at this hour, this activity, this object, which is an identifier of an order, we have this particular kind of deviation. So the deviation can be an object corrupted, a rule violation, a deviation in control flow, a non-proper termination. And also, we generate automatically a description of this deviation. For example, in the very first deviation, it says that the resource, the order, with that object identifier, has that even state, a tuple. But in the model, after executing that activity, trade 2, one of the attributes, in this case, I am not indicating it here, but it's the price. So you see the price after executing the trade was 105, but in the event was 100. So this means that after executing the trade, there was an update of the price that maybe is not captured by the model, or indeed it's an error that we have detected for such an order book. And the following principle goes for the another kind of deviations. So we have in which traces they happened, which events, which hour, which kind of deviation, and a description about the problem. So for concluding, what do we have? So I'm going to speak about the two sides, contributions on the two sides, on the application domain, trading systems and testing, and on process mining. We have a method to search deviations in trading system by checking conformance between event log, real behavior, and a colored net, expected behavior. Now, this conformance checking also can be seen as passive analysis. So to non-intrusively explore the system based on logs, on data. And this is something interesting, which I know it's a trend, in the area for validating 3D systems. So there is work about how to use data science techniques for exploring trading systems. Process mining and conformance checking is also a way to explore passively a trading system. And a final point here is that the file of deviations becomes very attractive to be leveraged by data mining of machine learning methods. So I will go just 1 second back. So this output that we have could be very interesting, how with data mining methods could be exploited to diagnose deeper the system. For example, we could study relationships here. Maybe at certain hour, a particular kind of objects has a certain deviation. So these are the kind of questions that we could make using this data and to answer it. Now, on the side of process mining, so we have a conformance method, a novel one, that we leverage, we exploit the formal semantics of colored petri-nets. These kind of models, colored petri-nets and high-level classes of petri-nets, is an active research direction in process mining. In our lab, in the PAIS lab, at the beginning of the year, during the first semester, we have a session. I am writing here the link, PAIS, HSC, RU, and seminar, PN. And in that link, you will find a lot of talks from world-class researchers that they were presenting different rich models, extensions of petri-nets to resolve different kind of problems in process mining. So this is an active area of research, the use of these rich models. In our research, we are working on this. So we use nested petri-nets, which is another extension, not for analyzing the orders, but for analyzing the behavior of the traders. And another direction is how we can integrate both. An extension where the traders, we can analyze agent behavior, but also the data of the orders. This is another direction that we had with researchers from Italy, Andrei Rifkin from the University of Bolzano. Well, with this, I finish, and thanks a lot for your attention.
Thank you very much, Julio. Just waiting for questions. A question for me. What are the main challenges and problems you faced when conducting this research in this area? Thank you.
Well, one of the challenges is how to transform this data. So it requires some expertise how to transform the fixed messages into an even log, in the correct data for pre-processing. So this requires some expertise to know what to transform. And then also on the model side, so what in particular we are going to model, which is not an easy task. Once we have these two inputs, the idea is now to compare it. So I think that.
Thank you. Another question. Can you please clarify how to assign the correct priority to the incoming order in the Petri-net?
So thanks a lot for the question. So I did not write it in the model, but in the Python script that we have, we can establish that for a certain transition, we verify for the binding that we have. So for example, we want to check if for order B1 and S1, they are actually the orders that should have trade with the maximum priority. So if they are really the next ones to trade, this is something that can be programmed in the script and also can be formally written. The thing is that in the model was not explicitly written, but this is something possible to do. So in the script, we configure exactly which is the priority. So to check according to one particular attribute. For example, in this case, we want to check that the price in the buy side should be maximum for an order, and in the sell side should be lowest. Also, we could configure the model in such a way to check another kind of priorities.
Are there, thank you very much. And other question, are there any other discrepancies between the model and Python script?
Well, the thing is that what it's in the Python script is an implementation of the model. So there could be some additional things related to the code, so specifically about the code that are not established in the model, but the core details, so how a transition transforms the orders, or this causal ordering between the transitions is in the model is exactly what we coded in the script of the model.
Thank you very much. Thank you, Julio.
Thanks to you.
Thank you. Goodbye, and we continue our conference with the next speaker. Now it's turn of Alexey Yermolayev, QA project manager, Exactpro company, and Nikolay Dorofeev, senior doc ops engineer, Exactpro company too. Alexey and Nikolay, are you here?
Yeah. Hello.
Okay. Now let's begin.
Okay, thank you. Hi, everyone. Thanks for joining our session. Our paper is titled Data Streaming Processing in Reconciliation Testing, Industrial Experience. The paper was authored by a group of people working at Exactpro. The names and titles can be seen on the slide. My name is Alexey Yermolayev, and today I'm going to present our research with my colleague, Nikolay Dorofeev. The structure of today's presentation reflects the paper contents. First, we will touch upon the importance of data reconciliation concept for the task of software testing. As part of the literature overview, we will discuss existing approaches to data reconciliation and data stream processing. In order to provide a business context, we will discuss how the data reconciliation task was solved at Exactpro in the first generation of the test automation tool suite. Then we will share the industrial experience around the data streaming analysis for the task of the reconciliation testing, and describe the solutions created at Exactpro. We will outline advantages and disadvantages of the approach and compare it to existing state-of-the-art data processing solutions. At the very end of our presentation, we will share the lessons learned and answer the questions from audience. Data reconciliation is usually defined as the task of matching records associated with the same entity but represented in different datasets. This task is typical for the systems dealing with data flows transferred between multiple components of complex platform. In financial technology, data reconciliation is crucial for market data dissemination. Electronic trading, clearing and settlement, and other areas of financial technology that involve matching data received from different channels or via different protocols. So complexity of IT systems increases dramatically from day to day. On this slide, you can see a typical exchange system. Different system components use some fractions of initial data. So to ensure correctness of the data involved in cross-component interactions, a lot of reconciliation checks are required. But complexity, it's not the only challenge. Processing power rapidly increases and financial platforms are required to process bigger data volumes and process them at faster pace. These trends create a new requirements for the data reconciliation approach. When it comes to complex financial systems, it cannot be simple field matching task. Such an approach needs to satisfy not only the data accuracy requirement, but also be suitable for the rule-based processing of large volumes of real-time data. This industrial need can be addressed by the stream processing paradigm that shifted the task from querying stationary data towards dynamic queries against real-time data. So let's look closer at the approaches to data reconciliation. Our literature overview has shown that, that there are several parameters differentiating them. One of them is data model. It defines the type of the data we use. It can be either persistent or continuously changing. Another parameter is data format. It describes the form of representation of database items. It can be tuples, objects, or XML structures, anything from text, strings, or numeric values to graph representations. Next parameter is the matching type. In different research papers, we have found the following examples. The most straightforward is exact matching, typical for the task of the data consistency accuracy checks or finding duplicates. Recursive field matching, represented by several matching patterns between data strings and substrings. And approximate matching, similarity of the data rather than exact match, mathematical approximations, and machine learning techniques. And the last but not least parameter is the matching procedure, which defines the type of the requests. It can be either streaming SQL queries or custom API requests running against custom data structures. Real-time data processing shifts from traditional database management system towards to new generation of tools called information flow processing systems. There are two types of stream processing solutions on the market, stream data integration and stream analytics. The first type of tools provides a lot of APIs, producer API, consumer API, connect API, which allows us to connect stream producers and stream consumers according to our needs. The second type is stream analytics, is represented by the solutions that process the data, applying certain user-defined algorithms. Rule-based analysis and reconciliation of real-time or near real-time data are quite heavily researched and implemented in the present-day tools. All of them create a very diverse external and industrial context for our streaming data reconciliation task. However, this context cannot be considered fully outlined without the preceding experience with internal software implementations related to the task. So some of our tools are on the slide. Shusha is the post-transactional passive testing tool for testing the backend of trading platforms and interaction between trading systems. It's also applicable for audit and certification. The tool uses fixed data model. Data format consists of database objects, exact and recursive field matching types based on SQL queries requests. TVR is a passive testing tool which allows to verify results obtained during both functional and non-functional test executions. The main purpose of is trading logic and consistency in all the flows. The tool uses a fixed data model, but data format could be different because it applies all data formats described in this research for different aims. Exact and recursive field matching types based on programmatic queries requests. The next one, MD Analyzer / Book Checker. This is a tool for building instrument books based on persistent data and reconciling it with programmatic queries requests. Book Checker uses tupled data format in combination with exact matching type. NFA Analyzer reconciles parameter from already stored different API flows, use XML documents for reporting. Exact and recursive field matching types could be configured with programmatic queries requests. And the last one that's shown on the slide, Mini Robots, is the first stream data model testing tool. It could simulate real traders' behavior based on programmatic instructions. Object-oriented data format correlates with all the matching types described above. So all listed tools, except one, perform reconciliation. They are different and intended for different aims. They have variable configs and variable logic. But one thing is common. They have passive architecture. The complexity of the systems increases dramatically. At the same time, business requirements couldn't afford to spend huge amount of time for testing. So real-time processing becomes the key idea on the market. With the bigger complexity of the systems under test, QA tools should provide a lot of flexibility in verifications and configuration. Based on these points, some time ago, we have started to develop a new testing module called Check to Recon.
To address multiple challenges and improve functionality range and the performance of test automation, Exactpro team created Teach2, a Kubernetes-based microservices toolkit for testing complex distributed transactional systems. Teach2 is a modular solution with testing components running within Docker containers. Check2Recon is one of these components. Check2Recon box consumes several event streams, compares messages in order to detect discrepancies in the data. In addition, Check2Recon can mark up the messages with notes signaling about potential problems. Before use, Check2Recon should be configured according to our purposes. We remember that Teach2 box is also a Kubernetes pod, so the pod's config contains some technical information such as a maximum number of stored events, cache size, and event sizing interval. The core of the data reconciliation functionality of the described solution is implemented through the concept of rules. Rules are special Python classes that contain the logic of comparing events. Rules need to be defined both on the pod level and as Python code. The working principle behind this class is as follows. For each rule, the getters associated with the rule name, description, and other attributes to be displayed in the GUI. Message groups to compare are described in a corresponding special getters, allowing you to define a group name and its type. At the moment, there are two group types. The type single means that messages in the group are allowed to have unique hashes only. All messages with duplicated hashes will be deleted. The type multiple means that the group can store several messages with the same hash. The group, hash, and check methods in the rule class are responsible for message processing, which is performed sequentially from a group to hash to check for each and every incoming message. The group method analyzes a message using an algorithm written by the user and sets the message group ID for the algorithm to be able to allocate the message to an appropriate group. The hash method generates the hash key for the message to be processed by the join-like query. The hash key is like a composite key in SQL databases and depends on one or several fields of the message. If values in all these fields from one message are equal to corresponding fields from another message, the final hash keys of such messages will also be the same. The check method is used to compare a given message with all messages from different groups having the same hash key. By its nature, the underlying programmatic query is not very different from SQL-like joins. After the comparison, the check method generates an event with a comparison result, depending on the logic defined by the user. After that, the original message is available for comparison with upcoming messages until it's deleted after timeout. Our industrial experience and attempt shows an attempt to include a data reconciliation model into a complex microservices-based architecture of a bigger test automation framework. The check-to-recon module supports both persistent and streaming data models, as the TH2 framework allows the testing systems to read the stored system flows data. For better fault tolerance, it would be great to use hybrid approach. When the message flow is too big to be processed in real time, the tool could start storing the unprocessed messages above the queue and continue analysis with a minor delay. Further, when the message flow becomes weaker, it could get back to real-time streaming analysis again. The tool allows for the data format to be highly customizable. TH2 is designed to store and process the data in a unified format, even if original protocols of data flows are different. The matching type used in the module for data reconciliation is completely configurable by rules, classes written by the user. We could configure several rules to work at the same time. As for the matching procedure, we followed the programmatic approach, developing a custom API for advanced processing based on user-defined logic. At the same time, the approach under the hood of the check-to-recon has ideas similar to SQL-like query structures. For example, hash is used as a composite key for message identification and search like a primary key, and two messages are matched if the hashes are equal, like in joins. Commenting on the implementation of the module, the choice of Python as programming language underpinning the solution has both advantages and drawbacks. On the plus side, the implementation benefits from simplicity and flexibility. It is also easy to use due to Python's popularity at a relatively low entry threshold, which is an important detail from the perspective of a user. The disadvantages of the implementation include limitation of using it in a single-threaded mode only, and relatively low performance. This model was developed as a proof of concept for streaming analysis via TH2, and it served this purpose well. Check-to-recon provides advanced rule-based reconciliation capability suitable for working with continuous message flows. Comparison of the tool with most present-day applications for data stream analysis shows that it is not the most efficient implementation of the reconciliation testing approach, but still it works well. All in all, we came to the conclusion that our primary aims are achieved. The idea of check-to-recon contributes to the development of software testing professional domain. Secondly, our contribution here is provided by outlining the lesson learned from the comparison of this custom-made component against existing tools. And finally, described experience will help to improve data reconciliation tool. Thanks for everyone. Now we are ready to answer your questions.
Thank you. Thank you very much. We have a question. Do we use mini robot in CUI versus FIX testing? Do mini robots verify if outgoing messages are still consistent? So you can read this question in our chat.
So our presentation and our article not about the mini robots in particular. So it's about TH2 and the special module. Okay. No, we don't use mini robots for GUI testing.
GUI. It was a mistake. CUI. Okay, thank you. Thank you very much. And we continue with the next speaker. So guys, goodbye.
Goodbye.
Thank you very much. Goodbye.
The next presentation. The next presenters. We have 4 presenters. Luba Konova, Livan Gribashvili, Tiniko Babalashvili, and Ivan Sherbinin from Exactpro company.
Thank you very much, Anna. Hello, all. I'm really excited and happy to be here today. And thank you. I thank you all online audience for coming to our presentation. Our topic is model-based testing approach for financial technology platforms and industrial implementation. We represent Exactpro team, and we will speak about how model-based testing is implemented for black box testing of complex systems, financial systems that underpin financial market. But let's first bring up some basic terminology. The previous speakers, they dwelled a lot on testing. I think it's clear for all that the main purpose of testing is to demonstrate that system under test are fit for purpose and to detect defects. And the definition of model-based testing given by ISTQB glossary is testing based on or involving models. But when we think of models, we need to outline the most significant features a model should possess. So according to Herbert Stachowak, a model needs to possess 3 main features. The first one is model is based on the original. The second, model only reflects a relevant selection of the original properties. And a model needs to be usable in place of the original with respect to some purpose. If we query model-based testing, we see about 8,000 results. And if we listen to today's earlier presentation, they see that this is a very broad area of research. MBT is being increasingly adopted to automate testing and bring intelligence to quality assurance. Let's just give some basic outlines. The notion of model-based testing, it dates back to 70s, and it was called double specification testing. And since then, MBT has received much attention, and when compared, and it was discovered that when compared to traditional testing approaches, MBT indeed brings increases both quality and efficiency of testing in comparison with so-called manual execution. But the MBT approaches vary significantly, and there exist myriads of technical proposals, and in last 2 decades, different variants of surveys started to appear, which try to classify and to give some structure to the existing experience in the area. Here on the slide, I listed here I found this two works, which we will use as a framework to describe our approach. And these are two most cited surveys. Another work that is mentioned here is by Mokt, Safi and al. This is the most recent survey on model-based testing, model-based test case generation, and model-based test case prioritization. What is interesting about this survey that initially they selected about 7,000 approaches. Then they narrowed their search to about 300 approaches, and only 1/3 of all articles they described real-world case studies that is originating in the history. And the authors of the research called the other 2/3, they were toy case studies, that is not fulfilling real-world requirements. And of all 300 reports, researches, only 1/10, that is 30, were real case studies that were open source and available. So the objective of our today talk is to speak about how model-based testing is implemented at Exactpro and how models integrated into H2 are used for the black box testing of financial ecosystems. Models themselves are proprietary since they contain customer-specific logic, but TH2 framework in which models are integrated is open source and available, and that's why we think that this research will be helpful for practitioners. So it's not the purpose of today's presentation to speak about TH2 in detail, but if you're interested on Exactpro site, there is a link to GitHub, so where you can see documentation and also the code itself. So today we'll speak about characteristics of Exactpro's MPT approach, directions of future developments, and also about assessment of the industrial experience with MPT outlined through analysis of survey responses. But I also would like to engage you as a public in these surveys. Andrei, could you please send all three questions, all three surveys to YouTube chat? So I'm asking you right now to validate three statements and say whether you agree or disagree with them. And then by the end of our today's presentation, we'll compare the responses with ones given by the Exactpro testers. Right now, you're welcome to respond while we are speaking, and only by the end. At the end, we will review your responses, and thank you for your participation. Now I'm passing the word to my colleague, Levan. So Levan, you're welcome. Yeah, Andrei, could you please bring back the presentation, and we'll look at the results of survey later.
Only I can't hear Levan or everyone else.
I think
I can hear you.
Apologies for some difficulties. Yeah, so thank you for your responses. Yeah, that's the third. Andrei is sending right now the survey to you. And okay. Thank you. So while we, okay, I see my calling has joined.
Can you hear me now?
Yeah,
Right
perfectly.
now.
Sorry. I'll continue. So we use the taxonomy of model-based testing approaches, which was introduced by Itkin and his colleagues. And as Luba mentioned, it is a paper which has highest citation rate on Google Scholar. And this taxonomy classifies models in 6 dimensions, differentiating between various model specifications, execution methods, and test generation techniques. You can see these dimensions here on the screen. And the first dimension is the scope of the model. So we have 2 different types of scopes, input only and input output. Input-only models can only generate input scenarios, while input-output models can also generate expected results for the scenarios. From these 2 categories, we classified our model as input-output. However, input generation in our model is very limited, so it would be more accurate to classify it as output only. The main part of our model is a test oracle, which is written in Python, and it can predict system responses for specified user actions. As the code is not written in a formal language, it cannot be used for generating scenarios. So users write scenarios manually while using combinatorial algorithms to generate input data. Next, I will move to second dimension, which is characteristics. Our model is untimed, deterministic, and discrete. I will explain now what this means. So timed models are mainly required for real-time systems where the exact timing of events is necessary. Our model is untimed. It only tests the functionality of the system under test. The timing issues are checked by the non-functional team. Also, the model sends all requests sequentially, and each new request is sent after we receive the response for previous request. And this avoids any non-determinism that may happen because of concurrency, and the model can predict any behavior in advance. So our model is deterministic. Lastly, our models and systems that we test are of discrete event type, as changes only happen at discrete steps. This is as opposed to continuous systems where some value may be changing slowly over time. This doesn't happen in exchanges. Next, we move to paradigm. Unfortunately, we couldn't classify our model based on the paradigms in the paper. As I said before, our model doesn't use a formal notation for describing the exchange logic, and instead users come up with scenarios and use the model just as an oracle. So this paradigm is not relevant to our model. But you can see what kind of paradigms there exist. We're currently researching using pre-post notations and transition-based models. But at the moment, we just use our model as an oracle. And next, we have test selection criteria. So this concerns how the model chooses test cases from the input space. In the screenshot, you can see an example of how users can specify input actions for the model. We use test case specifications, and also we use combinatorial algorithms that generate input data. And they are used to cover various different order configurations. So this is a part that is automated. And for test generation, we use a bunch of technologies. So we have a pairwise testing tool, which was developed in-house, and it also includes a constraint solver. So this tool is used to get the necessary coverage while reducing the number of test cases. And by specifying some constraints, users can make sure that only valid test data is generated. And for parameters that shouldn't affect the outcome, users can also use random generation. Aside from combinatorial methods, we also created a symbolic execution tool that can generate input data based on some specified logic. For example, we can find which order values will lead to that order being accepted or rejected. So it helps testers to come up with some valid input data for a particular test case. And the last dimension concerns how the tests are executed. We have offline and online execution. With offline execution, tests are generated strictly before they are run. We used such an approach in the past, but recently transitioned to online execution. With online execution, the model is directly connected to the test execution framework using TH2, and it can execute actions against the system and checks the observed responses. And this considerably speeds up the testing process, because with offline execution, testers would need to first generate an intermediate file containing a test script and then execute it against the system using a separate tool. So it was very time consuming. And with that, the classification is finished. And just to repeat all of it, I will go through it again. So our scope is input-output. Our model is untimed, deterministic, and discrete. We couldn't classify our model according to a paradigm. And for test selection, we use data coverage, test case specifications written by users, and we use 3 technologies: random generation, symbolic execution, and constraint solving. And lastly, our model uses online execution. Next, Tiniko will continue and talk about a different classification of our model.
Hello. Levan mentioned the classification by the taxonomy, so we decided to kind of choose another classification as well, which is suggested by DS Neto and the co-authors. For the first criterion, we have the software domain, which describes the type of the systems model-based testing can be applied to. Currently, our models are employed in testing of the trading platforms, which are large-scale, time-critical, complex infrastructures, and maybe in future perspective, the models might be applied to other types of systems which are associated with global financial market. Next criterion is test level, which indicates what types of testing are done by the models. In our case, these are functional and regression system testing, and I will explain what this means. Functional testing is process when the QAs determine if the piece of software is acting correctly and meeting the requirements or not. And regression testing means if the new release or new functionality affected the already existing functionalities or not. Automation level is basically the proportion of automated steps and non-automated steps. Our models tend to be fully automated. However, we have manual steps, which are, for example, testing data input or creating scenarios, which are done by the QAs. The next criterion is supporting tools. In our case, we do not use any external tools except for Exactpro's own tool, TH2, and the models are written in Python programming languages. Other than those, we do not use any external supporting tools. Next one is test coverage criteria. We are doing black box testing, so the data flow and control flow strategies are not applicable for these types of testing. So it still remains a question. So how we can measure test coverage for such complex systems as the financial markets are. Models need to be correct and accurately generate expected results. This is why models are continuously checked at the development stage to make sure that they meet the specifications as perfectly as possible. Next one is cost and complexity, which will be later discussed by Luba in more details. But at the stage of functional testing, at early stage of testing, model-based testing approach can be resource-consuming and time-consuming, but later in testing, in the long run, they are quite beneficial. This is how our models work right now at the moment, but we have future plans, and I will discuss them right now. Currently, our models are referred as active models. This means that after model is executed, it goes through TH2 ACT services where messages are sent. Then in TH2 codec services where internal messages are validated. Then TH2 connects to the system under test, and the expected results from the model and actual results from the system are validated in TH2. Our plan for future is to create a passive model which will be directly connected to TH2 and the system under test, but users will not be able to send messages via model directly, and the model will have a role of passive listener. Here we have the other plans for models. First one is external exchange stub. For testing smart road functionality, we need to stimulate the external exchange. External exchange stub means that model will serve as a smart stub, which will automatically provide the external exchange response based on the incoming messages. Another plan is interactive model, which means that testers will be able to connect to the user interface directly and send required messages to the system. And interactive models will kind of help us to widen our scopes of testing and will help us with exploratory and smoke testing. The aim of generic model is to make the models reusable. It will enable us to adjust the model in a better way to a new client. Generic model will include the basic functionalities which are present in all of the exchanges. Model-based testing approach definitely brings benefits, but they do not come without challenges. And Luba now will talk about challenges and solutions related to the model-based testing.
Thank you very much, Tinikor. So naturally, when introducing MBT into the real-life testing process, some challenges were met, and these challenges are well described in the work by Jan Palesker, industrial strength model-based testing, state-of-the-art and current challenges. And these statements were given to you in the YouTube questionnaire to see whether you agree with them or not. But let me first go through each of the challenge and speak how we cope with them in Exactpro and mitigate the relevant risk. So the first challenge is if complex models have to be completed before testing start, this induces an acceptable delay for the proper test execution. This is coped through processes in Exactpro. At the beginning of the testing project start, all stakeholders, the developers team assess the functionalities and it's decided together with the stakeholders which functionalities should be automated using model at a certain period of time, and models are developed iteratively, and that helps mitigating this risk. So throughout the whole project cycle, model-based automation is accelerating, let's say so. The second challenge is for complex system under test, like system of systems, test models need to abstract from a large amount of detail, because otherwise the resulting test model would become unmanageable. We do agree with this challenge, and we faced it. We cope with it by having a system of models. So each system covers a separate functionality, but it's still for us an area for future research, how to make our models clearer and more transparent to testers. And the third challenge is the required skills for test engineers writing models are significantly higher than for test engineers writing sequential test procedures. We do agree, but at the same time, previously, every test engineer had to indicate expected result in each particular automated test scenario, and thus test oracle was spread across all the library, and if there were any changes in test oracle, it was pretty hard to update all automated library. Currently, with the models introduced, test oracle is centralized and developer team owns it, and it's easier to adjust to changes in functionality in this way. And the development team who deals with models is actually smaller than test team. So now let's look at the results of the survey which you answered. Andrei, could you please share the results of the survey that we gave? Yeah, so the first challenge about project schedule. So we see here that the majority of participants strongly agree, 38%. Others, they kind of distributed across the scale. So let's look at the second chart. Again, 50% are strongly, I think these challenges faced a lot in industry, and I do share partially this feeling. So, and the next one, please. Okay, so 43% of respondents strongly agree with this challenge. Yes, every practitioner that would implement MBT indeed will face these challenges. Let's switch to the presentation and see how Exactpro testers responded to the similar survey. So our audience was about 130 people of testers having experience from 1 to 20 years, and they see that the results are different, although on all charts respondents tend to agree with those challenges, but I perceive that only for the second challenge, all respondents unanimously agreed with the challenge, that is that models need to abstract from a large amount of details, and looking at two other charts regarding project schedule and skills for test engineers, I see that these challenges are quite mitigated to some extent, as I see by the responses. So to summarize, model-based testing is a powerful tool, but model should be fit for purpose, and models should be sophisticated enough to address the complexity of the system under test. So in this presentation, we described how we applied model-based testing to the black box testing of the complex financial infrastructures. Thank you for your attention, and we will be glad to answer your questions. We have Ivan additional here, who is heading one of our models development team. who will help answer the questions.
Thank you for your presentation. Yes, we have some questions. First question for Levan. Levan, you mentioned how the model looks like in current dimensions. Can you tell us the next perspective? What is the next step in developing the model within these new dimensions? No, we can hear you. We can't hear you.
Anyway, we have answer in the chat, so we can read it.
Okay.
So for the first question, our aim is to come up with models that can generate complete scenarios automatically. We are currently working on using state-based approaches, so the next step will be to create a model with state-based pre-post paradigm. We would also like to have a traceability between model and specification. In such case, we would be able to use requirements coverage as test selection criteria. Do you want to add something, Levan, for this question?
We don't hear Levan. He probably has. If you want to add something.
Okay, you
Just
can
bow
write.
your head and.
So the next question is for Tiniko. Is it possible to run a code coverage to see if all branches inside the code are used during the test execution?
Yeah, I can. Tiniko, if you can you answer? Do you need? Yeah, I can answer this question if you're fine with it. So basically, we use model-based testing for black box testing. So we don't have access to the system on the test. That's why this code coverage, that is again a big area of research. It refers to white box testing. It refers to firms, companies that develop some solutions. So, but maybe in future for Teach2, when for the tools that we will develop, these methods will be implemented.
Thank you. The comment. I'm talking about the model's code coverage from Marina Solovyova.
Yeah, again, this model coverage refers to white box testing and refers to development process, not to black box testing.
I think she means something else. She means if we execute one test, if all the branches of the code of the model are employed. Can she agree that she means that?
Yes, she said. Yeah. Thank you. Thank you.
Well, so that depends on the tests. There are the core functions of the model, and there are very specific functions of the model. So if we are executing the tests which are like which include specific parts and core parts as well, yes, all the branches are employed. But if we are testing some specific functionality, then if that's what she asked.
Yes. Thank you very much. Good team of you all. So we need to continue. And now let me present the next speaker. Danila Garkovchenko, QA analyst from Exactpro company. Danila, I'm sorry if I made a mistake.
No, that's fine.
Okay, let's begin.
So hello everyone. My name is Danila Garkovchenko, and I'm working for Exactpro. And I'm a part of a non-functional testing team. I specialize in the testing of complex post-trade systems And currently our team is in charge of testing of quite complex clean platform. 2 years ago, our system was released into production, but it's still changing and we continue testing it. The life cycle of any modern post-trade system is quite complex. It usually consists of several stages, which are a sequence of activities which follow some business logic. At the same time, such systems have to process inbound transactions, generate outbound transactions, and etc. In other words, such systems have to perform various activities at the same time. So here on this slide, we try to show complexity of our testing system. So here in this picture, each square represents a particular component in our system. So there are more than 200 running such components in our system, which are deployed over 30 servers. Also, there are more than 100 scheduled activities which are executed daily. So during our testing, we often observe problems with them. For example, they can get stuck for hours or unexpectedly fail. So such problems create delays for business activities which are executed after the failed ones. Of course, our team has a monitoring system to track such problems. And it's possible to say if a particular event runs longer than usual. After this, it is required to find the root cause. But the main problem is here, it happens only after the incident occurs. Sorry. So we decided to check how we can optimize such process. Ideally, we wanted to predict any deviation and outages before they happen. To do so, we took a closer look on one of the type of logs which our system produces. It's components telemetry logs. As I said before, there are more than 200 running components in the system, and all of them produces such logs. So they contain information about the component's internal state. They updated each second and published to the text file. It's a really huge amount of data, about 30 gigabytes of data daily. So we decided to use machine learning techniques to process such data and get the results. So generally speaking, we have a task of some outage prediction based on previous activities. Such tasks can be applied to the different spheres. For example, we found a few examples related to automotive, banking ATMs, and other spheres. The most impressive results in all of these works were achieved by using the traditional machine learning techniques like random forest regression models. So we decided to try them first in our work. So now let's talk about the data. There are two sources where we got it. So the first one is a dataset describing scheduled events in our system. So each of such event can be described by using the following attributes. So it's a unique identifier, type of activity, start time, end time, and completion status. So on this plot, we can see a distribution of durations for all activity types. So also in this picture, we can see an example of what our regular business day looks like. So here on the x-axis we have a whole timeline of our regular business day, and on y-axis we have different activities which are executed in our system. So as we can see from this picture, some of the activities are executed only once a day, some of them are executed several times a day. So another source of data is telemetry logs. As I said before, there are more than 200 components, and all of them produce such logs. So here at the top of this slide, we can see a representation of what such logs look like. So it basically it is not structured textual information where each component has its own parameters and own format of data. So the first problem that we had to solve, we need to create a structured data set for all of these parameters. Another problem which we faced with these logs was its size. So during our testing, we collected hundreds of gigabytes of logs for the last 2 years. So here we needed to process such huge amount of data in easy-to-use dataset. To do so, we chose standard comma-separated file format, where each column was a particular parameter from telemetry logs, and each line represented a particular time on the timeline. So such approach allowed us not only to structure the data, but also reduce size of log by 93%. However, the amount of parameter wasn't changed, and we still had about 7,500 parameters, which are updated each second. So at this point, we had 2 unlinked datasets. First one of reasonable size of activities, and a really big one for telemetry logs. Hence, each event, for each event, we have one row from activity dataset and multiple lines from telemetry logs. It is because of each particular event lasts at least a few seconds, and for exactly for the same period of time, we needed to collect telemetry logs of 7,500 parameters. So it's a really such a really huge size of data doesn't allow us to work with it easily, just because of we don't need enough hardware resources. So we decided to try to find a way how we can reduce its size. And we decided to replace parameter vector update to a set of values describing how such particular parameter was updated. To this, we used the aggregate functions. We started with most obvious ones, like a minimum, maximum, and average values. So instead of the vector, let's say 1,000 parameters, we got just 3. Of course, we lose some data here, but we significantly reduce size of logs. After joining activity dataset and new telemetry dataset, we got a really wide table. But it was still possible to remove correlated columns and columns with constant values. So here on the right of this slide, we can see a full processing data pipeline which we used. So such approach allowed us to significantly reduce size of logs and get the data set easy to use for the modeling. Final size of the table was still big, but it was about 2,500 parameters. But it was much smaller than we had before. So now let's move forward to our research results. At the very beginning of our research, we decided to evaluate the duration for just one activity type. So here, in this case, the telemetry data was taken from first to the second to the last second of one particular activity. And using the decision tree regressor model, we got the following results. So here, on the x-axis, we have different runs of one particular activity sorted by real duration value. And on the y-axis, we have a duration in seconds. As the main metric to assess precision of our models, we chose root mean square error. It's the basic metric to estimate precision for regression for all regression models which we used in our work. So in all further experiments, we used the same metric as well. So as we can see, such results was unacceptable for us. But we see one positive thing here. So there is a correlation between the real value and predicted value. So, and the longer activities have a bigger RMSE as well. Also, as our main goal of our research is to create a solution to predict duration for a varied number of activities, the way to create a single model for each activity doesn't seem feasible. So we decided to create a single model to predict duration for all activity type. So here on this slide, we can see first results of our task. So such results were not good for us, as we can see from this plot, and it needed to be improved. So to increase the model performance, we decided to normalize the target value using the logarithm function instead of absolute values. As we can see on this plot, it allowed us to improve our performance. So here, the red curve shows the results before normalization, and blue lines shows results after normalization. Also, during all our experiments, we could see that the longer activities produced the bigger RMSE if we measure it in seconds. Even if for short activities, everything was fine. So to fix it, we decided to recalculate our metric using the following formula. So here in this case, our metric was calculated in relation to the target value, and it's measured in seconds. So it allowed us to reduce a gap between duration of short and long activities. And as a result, all activities contribute to the RMSE value equally. So after these changes, we compared the performance of decision tree and random forest regressor models. So as you can see on this plot, in the most cases, the performance of random forest models was significantly better. So here on this slide, on the y-axis, we have percentages, not seconds, which we had in previous experiments. On the x-axis, we have a number of runs of model at the same for the same initial dataset. So up until now, we compared the performance. We predicted the performance using the data from the beginning till the end of the duration of event. But the actual business scenario is to predict any deviations before workflow is finished. So here we decided to create three additional data sets with 25, 50, and 75% of initial data. So, for example, if the duration of such particular event was 10 seconds, for 25% data set, we took telemetry logs just for first 2.5 seconds. Then we compared results for these three datasets. So the results can be seen on this slide. Actually, we didn't see any improvements. It didn't see quality improvement here, and the performance was at almost the same level as for the models trained at 100% point. After this, we wanted to check one more thing. So we just joined all three above datasets into one with one additional column indicating at what point data was collected. After this, the model was trained using the same approach, and as we can see on this slide, the performance was significantly better. So this is the main result of our work. So at the end of this presentation, I would like to sum up our main achievements which we got during the research. So at first, we found the approach to prepare the data set of reasonable size. Also, we developed an approach for data augmentation. Also, our experiments shown that a random forest regressor model predicts activity with acceptable performance, but still there is a room for improvement here. And a couple words about our future work. So as we get some results for activity-based data set, we would like to prove that the similar performance can be reached for a time-based data set. Also, we would like to try to find other ways for data aggregation to get better model performance. And also find out how much data we need to start acceptable prediction in production runs. And after we get the acceptable results, we would like to focus on explanation of failures of our activities based on the telemetry logs which we had. So that's all. Thank you for your attention.
Thank you very much. For now, we have no questions, but I guess we will have them later. We have a Telegram chat, so please, if you want to ask questions to our speakers, you can use our Telegram chat, and we can discuss any topics there concerning our conference and our presentations. Thank you again, and now we will have a break till 1 p.m. at Moscow time and 5 p.m. Tomsk time. So we will see you. Join us after this break. What is
Yes.
your position?
I'm a researcher at Consensus.
Hello. Thank you for joining us again. We continue our work at the conference TMPA 2021. And let me introduce the next keynote speaker, Frank Casse, a researcher at Consensus Company. Hello, Frank. How are you? Are you ready?
Yeah, good, thank you.
Yes? Okay, let's begin your presentation.
So thank you, Anna, for the introduction. As you mentioned, I'm at Consensus, and Consensus is a company developing systems for the Ethereum 2 network. So in this talk, I'm going to talk about the formal verification of beacon chain, and I will introduce what the beacon chain is and what we did to verify it. So it's the conference is about testing and more broadly about verification. So I hope it's okay to talk about verification, formal verification, and not testing. So this work is a joint work with my colleague at Consensus, Johan Fuller, and a colleague at the Ethereum Foundation, Aditya Asgaonkar. So I'm at Consensus in the Trustworthy Smart Contracts team, and I'm based in Sydney in Australia. Right, so what is the beacon chain? So you may have heard about the Ethereum network, and the way it works at the moment is the Ethereum network is basically maintaining a distributed ledger, and the way it maintains a distributed ledger is in a decentralized and distributed manner. So decentralized means that there's no sort of central point of control. And the way it works at the moment is that you've got different agents in the network, and they all have to agree to build the sequence of transactions or entries that are going into the ledger. So at the moment, the Ethereum 1.0 network is working with what's called the proof of work distributed consensus algorithm. The next generation of Ethereum 2.0, will be running with a different system, which is a proof of stake. And so that's the bottom of this diagram. This is the Ethereum mainnet Ethereum 1, and the bottom is the Ethereum 2. And in Ethereum 2, there will be a special, let's say, specific chain called the beacon chain that will be somehow the orchestrator of the whole network. And in this network, there are participants, and the participants can be validators, and the validators are in charge of maintaining the distributed and decentralized ledger. So in this new version of Ethereum platform, the beacon chain plays a central role, which is orchestrating how the actually data are stored and so on. And also it plays a central role in deciding at each round and each level, I would say, in the blockchain. So you add blocks one by one, so there will be at different levels and height in the chain. You try to add blocks to the ledger, and the blocks are recording transactions that are happening in the system. So you can think about like maintaining bank accounts. Every transaction is a credit or withdrawal, and you update the state of the system, and you add the transactions in successive blocks. So there's a special chain in this Ethereum 2.0 system, which is the beacon chain. So it maintains the set of validators that are participants in the network, and because it's a proof of stake consensus algorithm, the validators have to stake some assets in the form of Ether. And this is the role of this beacon chain to maintain the set of, let's say, the balances of the validators, each to also make sure that the different validators can take turn in participating in the network. So it's not always the same validator that's going to propose what goes into the next block. So what transactions are selected to get in, it has to rotate and be fair and so on. So this beacon chain has a special status, I would say, in the whole Ethereum 2.0 network, in the sense that it's really the core of Ethereum 2.0 orchestration. So the specification of this chain are in the form of a state machine. So in this talk, I'm not actually going to talk about distributed systems, which is in a network like Ethereum, are the nodes and the participants get to agree on which transaction is going to be processed next. So that's taken care of by a consensus algorithm. But the beacon chain specifies what the state change is. So if you're in a given state, you've recorded a sequence of transactions in the form of blocks, and you get new transactions coming. What is actually the state change that is triggered by the addition of new transactions? So from a given history of blocks, a new block arrives, and there are new states to be computed, and that's what the beacon chain specification specifies. So each participant in the network has to implement this state machine that describes how the beacon chain should be working, and that's what I'm going to talk about today. It's about how to verify that this state machine behaves as intended. So if there are any questions, please, you can ask them now and interrupt me. Feel free to do so. So I'm not going to talk again about shards and other different layers like smart contracts and so on. I'm going to talk about the state machine and verifying that the state machine that implements the beacon chain is correct. So why is it important to do so? And what kind of formal verification and what kind of results are we expecting? So the first thing is that this beacon chain maintains a record of the stakes of validators, and they are staking Ether, which is a cryptocurrency. And if you've got lots of validators and the price of Ether, like it is at the moment, is high, the beacon chain is actually recording transactions that corresponds to a huge amount of assets. The second thing is that it's not obvious that the functioning of this state machine is correct, in the sense that the specs may be ambiguous and buggy, so that's not specific to the beacon chain, that's something that can happen for any system. And it's quite a big system, the beacon chain, so it's hard for developers to have a sort of a big picture and an overview of what's happening in the system. It's hard to understand. So the thing is that you can see the system as being buggy can have serious consequences in terms of, let's say, being taken offline or losing assets in the form of ether that you can never recover or things like that. So that's really important to verify that this can never happen. Another difficulty in the work we are doing, we've been doing, actually it's finished now, it was finished a few months ago, is that the specifications are, as they were standing before, they were given in the form of a Python-like language, which was not executable. So it's the syntax of Python, but it's never been executed before. And there's no clear functional specifications of the system. So you can see overall this beacon chain as a mission-critical system once it's deployed. So it's very critical in the sense that any bug in it could compromise the entire network. And it's similar to an embedded system because once you've deployed it, if you want to make changes to it, so you have to ask all the participants in the system to update their state machine. So they could be, absence of synchronization, different nodes not running the same system, and so on. So that could be very hard to patch and to fix. So there's a real incentive to try and make sure that the code is bug-free. So there are of course techniques that have been used to try and weed out the code and find some bugs. So the beacon chain has been implemented, or the state transition machine of a beacon chain has been implemented in different languages, executable languages. And for these languages, you can use a standard testing approach with lots of interesting findings that you can get, finding bugs and so on. But again, as it was mentioned by Dijkstra in the 70s, testing can find bugs, but it cannot provide and guarantee the absence of bugs. So in our work, we want to complement the testing techniques and use formal verification to provide a thorough analysis of this system. So what we agreed with the Ethereum Foundation, what we agreed to do is to report the problems we found and proposed issues. So our work was basically to try and prove that the system was correct. And when we discovered that there was something that could go wrong, we not only determined what could go wrong, but we proposed some fixes and proved that the fixes were actually correct. So they were actually fixing something without breaking something else that could have been broken once you repair a bug, right? When you fix a bug, you may actually introduce another one. So in our work, we use formal verification techniques, so this cannot happen. And what we delivered is a GitHub repository. I will provide a link later on, with the formal specifications of the beacon chain, with a correctness and termination proof. So correctness means it's a mathematical proof with the help of a proof assistant that the code does what it is intended to do. And termination is that every loops in the programs in the beacon chain terminate. So eventually they will provide a result. And we also in our work provided examples of implementations for the functions of the beacon chain. So in the next couple of slides, I'm going to give you a reminder of the techniques we can use to provide guarantees that the code is correct, and to introduce the tool and technique we've been using in this work. And later on, I will provide some examples of actual properties that we've been proving on the beacon chain. Right? So, yeah, first of all, I will summarize what the project scope was. So we set off to design a formal specification of the beacon chain. So from the Python-like specifications that were given by the Ethereum Foundation, we wanted to write a formal and mathematical specification of what the code is supposed to be doing. And on this specification, we wanted to provide some guarantees that the code was doing what it was supposed to be doing. And among the guarantees, we want to make sure that there's no runtime errors. So for instance, there's no arithmetic overflows when we compute on, let's say, integers or other numbers. There's no array out of bounds errors that can be triggered. So you've got an array and you want to show that every time you request an index in a given array, this index is actually exists in the array. You're not below 0, let's say, or above the length of the array. So that's the kind of proofs that we want to guarantee. We prove that all loops again terminate, and we provided also functional guarantees. So I'll show some examples later on. And on top of that, so that's what we want to prove. And what we want to do as well is to develop what's called a machine checkable proof that the code is correct. So you could provide, let's say, a pen and paper proof that this is happening, that the code guarantees some properties. But this is error-prone, of course. So what we want to do is to develop a machine checkable proof. So you write your proofs as programs, and there's a machine that can mechanically check your proof. So that's what we've been doing. So what is the technique that we've used to formally verify the beacon chain? So we used the OR logic, a system of a verification system using OR triples and OR Floyd logic. And for the tool, we used the Daphne verification-friendly language. So just a reminder of what it looks like, this sort of Floyd OR logic system and how we applied it. So the OR logic system of proof, so that's not for proving termination, that's for proving what's called partial correctness, is based on using separating a clear separation of the specification, what the code is supposed to be doing, or what properties should the result of a computation satisfy, and how the result is computed, which is the implementation. So I give here a simple example of a function. It's written using the Daphne syntax, but it's very similar to standard programming languages. So this function is supposed to be computing, let's say, the next power of 2 of a given number. So for instance, if this number is 3, the next power of 2 is 4, and so on. So what we want to do is, first thing is, you see that the typing system is that the integer you pass to this function can be an integer, so it can be negative. And we want to roll out computing this function for negative numbers. So we add a precondition to this function in the specification. So it's part of a specification. And this means that this function can only be called, or can only be called with a positive integer. And this is given by what's called a precondition. So in Daphne, it's written using a keyword which is requires. You can have as many preconditions as you want. And when you've got many, they act as a conjunction of all the preconditions that you list. So this is what we want to see. And then what we want to see when the function computes, so the body of the function is here, so it's a recursive computation. So when we start in a given state where the precondition is satisfied, so when we call the function with the positive integer, we specify what we would like the result to satisfy. So in this case, I say, okay, the result, if you start with the positive integer, the result computed by the function should be larger than 1. So what it means is that if we start the computation and the precondition is correct, if the body of the function terminates, then we would like the result to satisfy, we should have the result satisfying this postcondition. So you may notice that it doesn't require anything if the body of the function doesn't terminate. So for proving termination, we have to use a different device compared to pre and post conditions. But that's basically what it says. It's a contract between the function and the client that are going to call the function. If you call the function and the parameters verify the precondition, then you guarantee that if the function terminates, it will satisfy the post condition given by the ensures. So there's a few things as well that we can see on this simple function, is that In the post condition, I haven't actually specified exactly what the function is computed. As I've specified something which is an abstraction of what the function is computing, saying, well, it should be larger than 1. So it's not the exact definition of what the next power of 2 is, right? So you don't need to provide the exact strongest post condition of what a function does. You can use any abstraction that you like. So this logical reasoning system and the way of specifying, separating, I would say, specification and implementation was defined by Orr and Floyd. And now the question arises, if you've got a function and a specification and the body of a function, how can you prove that the body of the function, when it starts within a state satisfying, I mean, the input parameters satisfying the precondition, you run the function, you want to prove that on all of the possible computation paths, when the function terminates, the post condition, which is a predicate, is true. So how can you do that? And the way to do it is to use Orr-Floyd logic. They provide syntactic and semantic rules to reason about programs with specifications. And if you want to prove that the program is correct with respect to a specification, you have to use the rules of the logic and build a proof that demonstrates that starting in a set of states that satisfy the precondition, you end up in a set of states satisfying the postcondition for all the paths of the function. So I would say until the early 2000, it was quite an endeavor to try to use Orr and Floyd logic. You had to prove programs by hand and so on. So it was error prone. The rules are not well, they are precisely defined, but with a pen and paper you can make mistakes. The thing is that now there are proof assistants and engines that can somehow implement the reasoning rules that you can use in Orr logic. And one of these tools is a verification-friendly language called Daphne. So in Daphne, you write your program. So that's what I wrote before, the function, let's say, or many functions calling other functions. It doesn't really matter. And you equip them with pre and post conditions. And the Daphne verification engine, so it's a compiler, if you wish. The Daphne verification engine computes a logical condition called a verification condition. And this verification condition has a nice property, which is it's going to be valid, which means always true, if and only if your program, when it's executed, satisfies its pre and post conditions. So what Daphne does is it computes this verification condition from your program, and it then sends it to what's called a SAT solver or an SMT solver, which can determine whether this condition is valid or not. So if this condition is valid, your program is correct. If this condition is not valid, it can usually provide a counterexample why the property doesn't hold. So that would mean that there's a sort of a test where you start the program in a state with the values satisfying the precondition, you run it, and the result doesn't satisfy the post condition. So it's quite useful. And there's a third possible outcome, which is it's inconclusive. So basically, you use some resources, the Daphne verification engine runs for quite a while, and it can't find the answer. So this part is actually something that is inherent to formal verification for programs that are moderately complicated. So you may know that if you start with programs that can have two integer variables and do some simple computations, two counter machines, simple properties of two counter machines are not decidable. So this is why in this overall technique, you may end up with the system unable to define the result. And in this case, you have to try and help the system to actually find the proof. So the way you help the system to find the proof is in Daphne is that you can add proof steps. So how to prove that the pre and post conditions hold, you can add proof steps in your programs, and the proof steps are themselves written as programs. So the way you use the language is you start with the program with pre and post conditions. You ask the Daphne verification engine to verify it. If you're lucky, it's verified. If there is a counterexample, you have to fix either your specification or your program, and you iterate again. And if there is a timeout, you try to figure out what's missing in the proof and add some proof steps in the program and run it again. So that's an iterative process. Any questions at that point? So if there are no questions, I'll continue. So now, how did we apply? Sorry, clicked on the wrong slide. How did we apply this scheme to the beacon chain? So first, I'm going to show the different components of the beacon chain. So the main one and the central one is what's called the state transition component. This is the one I was mentioning at the beginning. It defines how to compute the new state of the chain. Where the chain is in a given state, there's a block, a new block of transactions happening, and it defines what the next block is. So it's a state transition function. So that's the main, I would say, bulk of the work is the state transition function. It's a state machine, and we have to prove that this state machine does what it's supposed to be doing. Included in the beacon chain, there are actually other components. So there's one that's called the SSZ and Merkleization. So this is basically a component which is a library that's used to encode the data structures used in the beacon chain to serialize them and deserialize them. So we've proved that component as well, but this is not part of it. It's not a state transition, it's a standard library serializing and deserializing data structures, but we've proved it too. And there's a third component that we have started to verify, but it's not in the verification of this component. We have provided it, but it's not integrated fully with the state transition. It's what's called the fork choice, which is proving that every node in the chain is going to build a canonical chain. So it's based on some properties and on a protocol and an algorithm that's defined in the paper. So we've proved some properties of this fork choice protocol and partially integrated them in the proof of the state transition. So notice that this actually, the proof of the fork choice was not initially in our contract with the Ethereum Foundation. We didn't have to do that, but we tried to do more than we proposed and to extend it to more high-level properties. So all these results and explanations and the code of specification is available in this repository. So in the next few slides, I'm going to show you some examples of code that we have written in the verification language Daphne, and to illustrate how we have proved these three components, so parts of these libraries, the state transition function, the fork choice, and after these three examples, I'll demonstrate a bug that we have found in the system that's a non-trivial bug and was not found before by testing. So that's something that I will show you how to, well, I will illustrate this talk with how we discovered this bug. So let's start with the SSZ and Merkleization. So as I said before, this component is a separate one compared to the state transition, and it's a specification that describes given an object of a given type in the beacon chain standard types. They have their own types. There are tuples, lists, and so on. So you serialize them into sequences of bytes, and you want to be able to deserialize them back. So this is basically when nodes have to communicate over the network. They're going to serialize data structures in sequence of bytes, and then you send them to another participant, and the other participant can deserialize them if they know the type to retrieve the information that was sent. So I've got an example here. For instance, in the beacon chain, there are data structures that are lists of bits, and lists of bits are encoded into lists of bytes, which are 8 bits wide. And the serialization process, for instance, you take this list of bits, you're going to copy it and then add enough bytes to span over the length of this list. And to serialize it, so to make it a sequence of bytes, you add a sentinel, sort of a sentinel 1 at the end of the list. So this encoding would be, you've got the initial list, and to serialize it, you add a 1 at the end. and then you pad with zeros, and you get 2 bytes. So this list would be encoded as these 2 bytes and sent over the network. So when you deserialize it, of course, these bit lists, you do the reverse operation. So you start from the right-hand side, you look for the first one, and then you know that this is the sentinel, so it's not part of the list, and then you take the previous part to deserialize. So there are other data structures in the beacon chain, tuples, integers, what do they have, vectors, and so on. So this kind of serialization and deserialization operations are defined for each of the types. And of course, you can compose these types as well. So a property that you would like to see in this system is that when you serialize a data structure, you send it over the network, and at the other end, another component is going to deserialize it. It should be the case that they retrieve the actual source component. So a property that you want to prove is that if you take an object O of a given type, you serialize it, and then you deserialize this object that was serialized, you would like to find exactly the same object. So that's called an involution or identity property, if you wish. So that's something that was the main property to prove about this component of beacon chain, the SSZ and Merkleization library. So this is what it looks like in Daphne. So in Daphne, as I said before, you saw some example before of a function with the pre and post condition. So in Daphne, you can write special functions that are called lemmas. So lemmas are just standard functions, but they don't need to be executable. And this lemma is a proof of involution. So it says you take a data structure, which is, in this case, it's not a container, not a list, and not a vector. So we prove this property for different types, but this lemma is for a subset of the types. And the proof goal is that the two functions, so there are two functions, serialize and deserialize, and we prove that the composition of these functions produces always the same value in the form of, so from S, you find S, and it never fails. This is the sort of the meaning of this success data structure. So this is the shape that this can take in the verification language Daphne. So when you use Daphne, you feed Daphne with this program, and Daphne is going to automatically check whether this lemma holds using maybe other sublemmas. So this actually function call is a call to another lemma, and it's going to compose everything, and with its reasoning engine, try to prove that the post condition for this lemma is satisfied. So it's again a fully automated process. You try to ask Daphne whether this program is correct, and if it's correct, you're happy. If it's not, you'll have to provide some proof steps in the proof of validity. So as you can see here, I've provided some proof steps. For instance, I've said depending on the type of objects that you have, it's serializable, and serializable is a type that can be subtyped into different type, bit list, bit vector, and so on. So for certain types, I say if you want to build the proof that this property holds for S being a bit list, then I provided the proof for this bit list in this lemma. So you can apply this lemma, and you compose the applications of lemmas, and you find the proof for this type bit list, and then you can enumerate the different subtypes and build the proof for each of them. And so Daphne is going to check that this composition and these subproofs, they are organized in a correct manner, they are all true, and then we can deduct that the conclusion is true. So this was the first component we started with, which was the simplest one in the specifications. It's a serialization, deserialization component, so that was not too hard, I would say, to start with. So I'm now going to give an example of the state transition function. So this is the one, again, that takes care of adding blocks. When there's a new block arriving on a given state of a chain, it has to compute the next state of a chain. And so basically, there are a few things happening. So in the beacon chain, so state change occurs every time a new block is taken into account, arrives. So the order in which the blocks arrive is taken care of and decided by a consensus algorithm. So we assume that this is decided, and the given node that we are trying to prove the correctness of receives the block, and we're going to prove that the state transition is computed according to the specification. In the beacon chain, the time is divided into slots, and the slots are grouped into what's called epochs. So if I remember well, an epoch is 32 slots. What's happening and why it's not trivial to prove properties of a beacon chain and the state change is that when the block arrives within an epoch, you've got some updates. And when the block arrives at the border of an epoch, so you change epoch, for instance, there are more complicated updates that are computed to update the state. So they are more complicated because they basically, at each epoch boundary, they build a summary of what's been happening before. So you somehow, in the state change happening at an epoch boundary, you're going to take a snapshot of the previous epochs, and that's building this snapshot is non-trivial. So I'm going to illustrate this with an example and tell you what we did as well. So our proof strategy was, we started with the imperative implementation of the Python specification somehow, or Python-like specification of a beacon chain. And from there, we tried to synthesize a functional definition of what the code should be doing. So if you wish, this Python-like specification will tell you how to compute the next state. And we use this as a reference to try and compute a mathematical definition, a functional definition of what the next state is. And we did that for all of the functions in the beacon chain, which is, there's quite a few dozens of functions. And our strategy was, once we had synthesized these functional correctness properties, we tried to prove that the Python-like code, so I've illustrated here a sort of a function state transition with the call graph of this function state transition. So once we had synthesized the functional correctness property, we tried to prove that the Python-like code satisfied this functional correctness property. So the outcome of this process was that we had a reference functional specification, so which is interesting for a few reasons. The first one is because it's the functional correctness requirements, we can compose them quite easily because it's a function composition. So we can basically very easily say what's happening when you compose over a few steps the state change. It's also good if you want to open up, let's say, the participants to write their client code into a language that's not Python-like, that's not imperative. So if you want people to be able to write their client using functional languages, it's good to have a functional reference. And it clarifies quite a lot of things. So among them, I would say the most interesting one is that in the imperative implementation, you've got how the state change is computed, and this code is actually quite tricky. There are lots of assertions in the code, so assert statements, and so they can be nested. For instance, if you see this call graph, you call state transition, and state transition would call process slots and so on, and in all of them, there are assert statements, and the specification, the imperative implementation actually of the beacon chain says that if one of the assert statements fails somewhere, then the state transition function should revert to the previous state it was in. So somehow you abort the computation. The problem in this kind of work is that you start state transition with some parameters, and then if it fails somewhere, you don't get a reason why it has failed. Was it because you provided some ill-defined parameter, or because of a mistake in the implementation, and so on? So providing a functional correctness reference specification is very helpful in the sense that it enabled us to say, if this property is satisfied, then the state transition function should not fail. So that's something we contributed to. And on these functions, the outcome, the results we contributed were that we proved for all of them the absence of runtime errors like overflows, underflows, division by zero, array out of bounds, and so on. That every function that would contain loops, we could prove termination of the loops. And again, we could prove properties beyond runtime errors, functional correctness properties, that the functions were computing things according to what they had to compute. So an example, for instance, is when you compute the chain, the beacon chain, it's actually represented because there can be many asynchronous actions. It's a tree, but you would like to prove that there's actually only one one way to go back from each node to the ancestors of a node. And when you go as much as you can back in time, you end up in what's called the genesis block. So that's a property that we proved on the Python-like implementation. So I'm going to take an example of a state transition function and one of the functions that's called in it to show you how it's encoded in Daphne again. So that's quite a lot of, I would say, conditions and postconditions. So just to illustrate what I was saying before, we have, for instance, synthesized this condition which tells us when a block is valid. And when the block is valid and can be added to a given state, this function state transition should not fail. So that's what we want to prove. So compared to the previous implementation, this is real progress. The other thing that you can see is in this postcondition. This postcondition, we have to ensure that the next state that's computed is equal to our functional definition of the computation. So these three functions, update block, forward state to slot, and next slot, they are functional definitions, reference definition of what the evolution of the state is, and we prove that the computation in the imperative code that I haven't showed here, but this code is imperative, there are loops and so on, computes exactly the same thing as this functional specification. And also other properties, we can add as many properties as we want. So this is quite tricky, and of course, if you have a method like state transition, and I mentioned before that, sorry, I'd like to go to the previous slide. Yeah. So state transition calls a process block. To prove properties of state transition, you'll have to prove properties of process block. So that's what we've done as well. We prove properties for each of the functions. And again, we've used predicates to specify when things should not go wrong. So this is another example here. If we have a valid beacon block body, which is a part of a beacon block, then we want to specify that the code should compute something that ensures the postcondition. So in this case, the computation should not fail. There shouldn't be any assert statements in the code that would fail. So that's the computation of the state transition function. So I'm checking the time. So one last thing we did on the side as well is to prove that the fork choice protocol is correct. So I'm going to skip this part because I see that I'm at 40 minutes already, and that's not essential. And the result is in the repository. You can have a look at it. I'm going to focus on one interesting point we discovered. It's in the GitHub repository for the Python reference specification of a beacon chain. It's the issue number 2500, and there's a possible array out of bounds. And I'd like to convince you that formal verification was, I'll try to convince you that this was very useful to find this problem. So this is in one of the functions of beacon chain. So this is the example of the code written in the Python-like implementation in the beacon chain definitions. So there's a function called process rewards and penalties. It calls a few different functions, and it ends up calling get attesting indices. So no matter what these functions are doing, that's the sort of the call graph of this. And it turns out so I can't see. Right. So get attesting indices. So the last function that's called in the chain. Yeah, the last function that's called in the chain is illustrated here. And in this function, there's a sort of a filtering happening. So this line says you take all the indices in this list committee. You take all the indices in committee, you arrange over them, and you select the ones. You take an index and you select the ones for which a bit, an array, an element in an array bits is true. So we're going to filter this set of indices in the enumerate committee and take only the ones for which the corresponding index in bits is true. So if you want to prove that this function is correct, you have to prove that there's a sort of properties between the length of this committee and the length of the bits array. Otherwise, if this index can go outside of the bounds of the bits array, you've got an array out of bounds error, a runtime error. So this involves actually showing that because we have some constraints in the definition, the length of bits is given. That's given by this constant. It's max validators per committee. So this amounts to proving that every time we call this function that computes committee, we call getBeacon committee, we have to prove that getBeacon committee returns an array, or a list, with a length less than the maximum validators per committee. So during the course of this proof that my colleague Johan worked on for quite a few weeks, she discovered a few interesting things. So she discovered that it's not always the case that they can actually be an array out of bounds error. So she discovered that for another parameter in another function, if this parameter is less than 4 million or something, then there's no array out of bounds. She could also prove that if this parameter, which is the number of what's called the active validators in the system, is between two different values, then there's at least one other input. So you see that there are a few inputs to these functions. As there's one input vector, if you wish, that will create an array out of bounds. And if this value is larger, so there are lots of active validators, then it doesn't matter of the input. There will be an array out of bounds all the time. So this bug was far from trivial, and it took quite a few weeks to actually narrow it down, and then provide a fix as in the form of a precondition to make sure that this is not happening. So the detailed issue has been reported in an extensive bug report. We've reported quite a few issues on the Ethereum specification GitHub repository. So if you're interested, you can have a look at the Ethereum specs repo. So what are the limitations, assumptions, and simplifications that we've made in this work? So there's a few things we've done. So for instance, concerning limitations or abstractions, I would say, there's lots of crypto functions in the code, so like hash functions. And in our code, we haven't had to assume any specific hash functions. The only thing we had to assume was that we assumed actually that there was no collision. So we haven't proved any probabilistic properties about the code. We assumed no collision and proved the rest of the properties. We haven't actually, let's say, used the actual types that are used in the SSZ libraries in the state transition proof. We have used the Daphne types to simplify. And we have not taken into account randomness as well. So in the code, there are some randomization that we haven't actually modeled. The simplifications we have made are pretty, I think, reasonable. So in some of the proofs, we have used the Daphne data types rather than the actual data types that are used in the beacon chain. We have also assumed that there are stakes for validators, and it's 1 ether instead of 32 ether. It doesn't make a big difference because everything is a linear combination in the formulas of this standard value, so that should still work. And we have also provided some bounds and some proofs about the fixed amount of ether and the maximum number of validators that can be in the system and so on to prove that some properties are correct. And of course, there's a big assumption in our work, which is we use a verification-friendly language, Daphne. So Daphne itself as a verifier computing this, let's say, verification condition, plus it outsources the satisfiability check of this condition to a solver Z3. So we have assumed that this is sound. So we don't need it to be fully correct, but we assume that the Daphne plus Z3 is sound. That means that if it declares that the program is correct, then the program is correct. It could declare that the program is incorrect and it's actually correct. That's incompleteness, but we've assumed soundness to make sure that there's no bugs that can escape us. And for some of the proofs that we have done, we have translated the Python code, Python-like code, into Daphne-like code. So we assume that the semantics of the two languages are similar enough. It's a sort of a shallow embedding of the code of Python in Daphne. So we assume that the semantics is preserved. And finally, a few numbers. So in terms of verification effort, this was equivalent to 24 person month. So there was one person, I was actually the expert in formal verification, and my colleague Johan was new to formal verification, but she she had an advanced level quite quickly, so I wouldn't say it's a problem. We have also worked together with the Ethereum Foundation. So we had our colleague Aditya from the Ethereum Foundation helping us to navigate the original Python-like specification. We also organized a few focused reading groups to read papers on the different parts of the beacon chain. And at the end of the project, we organized as well Daphne coding training sessions for the Ethereum Foundation specification writer to try and help them to read our code. And overall, this project we think is in terms of the size is in the top 5 projects ever written in Daphne. So there are not too many, but it's probably in the top 5. So in terms of contribution as well, we fixed a few bugs and issues, but our, I would say, work contribution is a bit beyond these concrete bug fixes and discovery. It triggered some discussions on how to write specifications and so on. So it was quite a good and fruitful discussion with the software, I would say, original beacon chain specification writers and us to try and find a middle ground into writing specifications that can be understood by developers as reference specifications and specifications that are actually formal and we can reason about them. So the code itself, we have used the language Daphne. We estimate that we have verified 85 to 90% of the functions in the beacon chain. We haven't modeled all of them. There's a few that we haven't taken into account. We provided more than 20 bug reports and fixes. We provided also bug reports for the Daphne language too. We've proved around 250 theorems. So some theorems are hard to prove, some of those are easy to prove. So it's not the number that should be, I should not show off with the number. Some of them are easy, some of them are hard. We've actually done something which is quite useful as well. I think it's, there's the lines of code of the specification, formal functional specification, and the Python-like implementation in Daphne. But we've added almost 5,000 lines of documentation to a la Javadoc to document the code that we have written. And that was a joint effort between the Ethereum Foundation and Consensus. So I'm almost to the conclusion. We think the impact is, we've been congratulated by our colleagues for the impact we had in the sort of a trust that we can put in the beacon chain. So we've got the formally verified kernel of the SSZ, Merkle, fork choice, and the beacon chains. The proofs are machine checkable, so you can write yourself. In our GitHub repository, we have a Docker container that runs Daphne and can check the proofs. The specifications that we have, as I said before, are language agnostic somehow. They are functional specifications. Of course, they're written in Daphne, but there's nothing specific to Daphne. It's mathematical functions. And it could be a candidate if people would like to refine it a bit more to be the reference specification for the beacon chain. And it contains the documentation as well for all the data structures and the functions, what they are doing, and so on. I think during the course of this project, we've also tried to foster the use of formal methods in this ecosystem. And we wrote blogs to explain what we were doing. We gave talks and wrote papers and so on. And we even tried to evangelize the people at the Ethereum Foundation by giving them some training on using Daphne. So overall, we improved the specifications of the beacon chain, but there's still some work that could be done. There are things that we haven't fully implemented, so this would require actually quite a lot of hours to be spent. That's quite tedious, but we think it's not going to help find any other bugs, so that's why we haven't pushed the boundary and tried to implement these leftovers. In terms of resources, I would say, so just to show you some reflection, the resources to write the original Python-like specification, there were 8 average specification writers. For the verification, which is a task that you should think is harder, there were 2 people, Joan and myself. So we managed to prove quite a lot of things, I think, considering the restricted number of people. So that's one one conclusion I would take actually for these kind of projects, if you have a team writing the code of 8 people, software developers, I would say, and you want to verify it, you should probably try to match the number of people to do it. Otherwise, the effort is limited. We've done what we could, but with more people, we could probably have done a bit more. So the main, I would say, difficulties we encountered during this project were that the original Python-like specs were not structured. So they were even sometimes, they would not type check because they've never been written in an executable language. The fact that the sort of the correctness of the code is implicitly defined by exceptions, so that's very hard to understand. The fact that data structures, for instance, are sometimes almost duplicated, so there are variations of them, but they could be probably bundled into one data type. It is not easy to reason about. When we use the language Daphne, there's sometimes limited support in the IDE, so you have to it's a new language, or well, not so new, but with limited support. It's not as well supported as Java or Python and so on. There's some sort of instability as well in the Daphne proof engine. So sometimes you don't understand why a proof that would verify before doesn't verify in a given time now. It's not because it's not true anymore, but because of the changes into the internal verification engines. So it doesn't change the result of the outcome of the verification engine, but it changed the time, and this instability can be quite tricky to manage. So overall, I would say the lesson we learned as well is, I think it's only us, but it's very hard to verify code that has not been written for verification in mind, and that's what we endeavored to do, and that was a difficult process. So we would advocate for using, let's say, verification at an early stage in the project if you want to use it effectively, because the later you use it, the harder it becomes to be fruitful and productive and effective. So there's a summary of the resources and the code and the paper that we have recently written, summarizing our experience with this project. And I'll be very happy if you have any questions to answer them. And I thank you very much for your attention and for inviting me to talk about this project.
Grant, thank you very much. And thank you for your presentation. We have some questions. 2 questions. The first question is, how do you fix a bug and ensure that you do not introduce a new bug?
Mm-hmm. Yeah.
I'm sorry, we don't hear you.
Oh, yeah.
Uh-huh.
I clicked twice, I think, on the unmute button. Do you hear me now?
Yes. Mm-hmm.
Yeah. So in the code that we write, each function has its pre and post conditions. And every time we change a line in the code, we rerun the verification of all of the functions. So if we fix a bug, or if fixing a bug is usually adding some code or changing some code, we rerun the verification of all the functions. So we show that this bug does not appear anymore. And moreover, all the other specifications that we had before are still satisfied. So that's how we make sure that fixing a bug does not introduce another one.
Thank you. It was a question from Yusra. And the second question is, how do you handle the complexity of the verification task? And could you please tell us a bit about the scalability?
Mm-hmm. So I would say the scalability, I somehow touched upon it, or the complexity in the last slide. So what we did was to identify, with the help of our co-author Aditya from the Ethereum Foundation, to identify simplifications that we could start with. So to make it a bit less complex and start with something simplified that we could work on and prove. So we had to make some choices and say, okay, we're not going to model complicated. For instance, there are attestations in the code. We modeled, there are 5 different types, and we modeled 3 of them, not the 5 of them. Again, the validators, you know, they can stake 32 ethers or more, and we decided that they would stake 1, which is easier to manipulate and things like that. So I think managing the complexity, and that's where the work of people who are doing verification is useful. We can try to build some abstractions that are somehow plausible and will enable us to prove some properties of the code without missing anything that could be an error. So it's I would say the job of the expert in verification to try and make some plausible and reasonable abstractions so that you don't lose too much information. You can still prove some properties without missing bugs. So that's how we manage, I would say, complexity. And scalability. So I think scalability, I would say, if you start with a project that's already written and you try to prove it, that's very hard. We have to somehow reverse engineer how it was set up and so on. So that's hard. So I would say scalability, I would try to solve it at the design level, which is to start with verification and try to synthesize and refine to a code that's executable and more complex, and use a refinement approach, starting from high level and abstract specifications and refining them step by step. So that's how you can, in the big Daphne projects, for instance, that's what they did. They started with a high level specification, prove some properties, and refinement steps to go down and complexify and make the system more precise, and that's how they manage the scalability.
Mm-hmm. Thank you very much. Thank you for your answers, for your presentation.
Thank you.
And I see no more questions. So thank you, and we continue with the next speaker. Okay. So see you, Frank. And now let me introduce Maxim Bakayev, Associate Professor at Novosibirsk State Technical University. Maxim.
Can you hear me?
Yes, we can hear you.
Can you see my presentation?
Yes.
So shall I start?
Yes.
Okay, great. So thank you for inviting me to present my paper. Actually, that was done with my master student, Maxim Shirokov. That's a topic maybe not very common for this TMPA conference because it's dedicated to user interfaces. So far, I've mostly seen the analysis dedicated to code, but I think that user interfaces are also pretty important. So I'm going to tell about some work that we did related to kind of automated testing or assessment of user interfaces. So do you see my slides changing? Okay, that's fine. So a few words about the motivation. So why do we want the automation of this? Because, well, each user interface works in a specific context of interaction. And if you consider the number of websites that we have nowadays, the number of mobile users and web users, each of which are basically different, and also the number of devices for each of which user interface has to be tailored, then you can see that it's no longer possible kind of to just handcraft user interfaces like we used to do, like the designer or a graphic designer or web designer or UI designer or user experience specialist, whatever. They do not have the economic capability to craft every interface. So we need automation in this field. And the traditional approach is the same as analyzing the program code. So basically you take the code of a user interface and perform the analysis, which is a sort of static testing. So you have the code and you analyze it, and actually it's proven to be quite successful in some aspects. for example, to checking accessibility aspects, compliance to, for example, usability standards, and so on. And also, it's pretty easy to do with the code, particularly for web user interfaces, because HTML and CSS, they usually easily accessible. So you just take the code of any web page that you have and you're ready to analyze, basically. But still, there are some restrictions, some things that this type of analysis cannot do. So we are, with my team, working in the field of visual analysis of user interfaces. So it's a dynamic testing in a way. So, for example, a web interface has to be rendered in a browser. And then we can take this screenshot or whatever and use today's quite advanced image recognition technologies, for example, to recognize UI elements, like you can see in this picture. Well, it's still computationally pretty expensive, so depending on the kind of fidelity, what exactly you want to extract and test, it might take tens or even hundreds of seconds for each screenshot. And also, you need quite a lot of training data to, for example, identify the UI elements, because the machine learning models that we have, they are usually tailored to general images, not to user interfaces. And getting enough training data is not always easy. But the advantages is that this kind of analysis can see exactly what the user sees. So you can analyze layouts, some color-related aspects, sizes. For example, they might be important for some elder people or something. And also, you don't have to care, kind of try to model the device. You just render it in a platform that your target user is going to use, and you just have what the user will see. So also, it's, well, understandably, unlike analysis of code, it's useful for analyzing some visual perception related aspects, such as visual complexity, visual aesthetics, and some emotional aspects, which are pretty important nowadays. So we actually had a previous publication. You can see the reference at the bottom. And in that work, we proposed the method for kind of overlaying a grid, the layout grids on real web user interfaces. It roughly corresponds to a Squint test that you might know from usability engineering, when you just squint at your design and trying to make sense of it. Basically, you decrease the visual fidelity, so you don't see any individual elements anymore. But you want to know if you can still make sense about the visual organization. What is the header, what is the footer, what is the main text or image, and so on. So you still want the layout and the visual hierarchy to be graspable. So what we did was also that we overlaid a two-dimensional grid over images of web interfaces. And we assigned either 0 or 1 in each cell, depending is there mostly content in the cell, then it's 1, or is it mostly just some blank space or maybe white space, just some background. That would be 0. And it's a way, in a way, it's a reverse engineering, because that's how the user interfaces are designed. Because designers nowadays, they align elements to grids. And because we don't have access to the mockups, understandably, we just want to analyze any user interface possible, then we kind of take a step back to the design. So this way, we eliminate some details such as colors, some styles of UI elements and so on, but we keep, as I said, the visual hierarchy. So that's especially good to analyze the layout. And especially, we kind of highlight the Gestalt principles. So it's a model for the perception in a way. And well, a few words about that, of course, you know. This school of Gestalt psychology, which was not as much about psychology as about perception, actually, it used this principle of arranging kind of what a human thinks comes in a group and what does not. So probably the main principle of grouping is proximity. So in the example, you can see that you perceive on the right kind of the three groups of elements because of the principle of proximity. And also they identified principles of similarity, similarity in shape and color and size and so on. Also, there were some more, and also some interesting things how your brain tries to make sense out of everything. So you have some random black and white objects basically, but for example, in A you see a triangle and some squares. So your brain tries to organize it in a meaningful way, in a more simple way. And that's actually, your brain can do a lot of tricky things. For example, in this illusion, most people would say that the square A is darker than the square B, right? But they're basically the same. So you can see that there is no difference, just your brain compensates. So actually, the existence of Gestalt principles is supported by a lot of research work. There's soon going to be 100 years. So in our previous research work, we had kind of a manual implementation of our approach. So we relied on students who would just overlay the grids manually on the websites. So the result would look like that. You can see zeros and ones. And naturally, we wanted to automate that because, well, 20 websites is nothing, and manual work is too labor intensive. And in that work, we actually, why did we want that? Because we found out that our approach to kind of predict visual complexity without humans works pretty well with compression algorithms such as deflate and RLE and Higgs law. So we built some regression equations in that paper and found that we are able to predict how complex a website would look to a user. So that's pretty interesting. And of course, as I said, we wanted to automate that. So the research objective of our current work is that we want to automate the construction of these layout grids on top of screenshots. And we developed a software tool for that that implements the algorithm. And we relied on OpenCV, of course, and also did some programming. And then we performed the validation of this with almost 500 of websites and assessments of visual perception that we collected from 70 subjects. So now in more detail about the algorithm. The first step was edge detection. Well, actually, I need to say that that was the implementation by my master student, and we mostly relied on pretty standard, a combination of pretty standard approaches, but I hope that we put them together in an interesting way. So we removed the noise and clutter and the gradient, and then we performed the edge detection using a pretty conventional command. And then we get some, well, out of the image of UI, we get something like that. So in the next step, we want to pixelate the image so that the pixels are kind of more obvious for the algorithm. So we would reduce the size of the image, and then we would recover it to the original size. So again, OpenCV function, a pretty conventional resize function. And then we get out of the edge detection that we did in the previous step, we get a pixelated image which looks something like that. So then we want to actually overlay the grid onto the pixelated image. So since the websites are generally first organized by columns, so first designers decide how many columns they're going to have, and then in each column they arrange the elements. So our algorithms also starts the analysis by columns. So it wants to draw vertical lines. It looks for continuous segments of black and white pixels, and depending on the several parameters, it decides whether or not it should make a column here. And then the same is done after we have identified the columns for each of them. Independently, we identify the rows, so what elements are basically located in each of them. So, and on this step from the pixelated image, we get the grid looking something like that. And next, we want to code the cells. So we want to assign either zeros or ones. And actually, excuse me, this is not straightforward, because it might depend on the perception of different categories of users. For example, something that would look cluttered in a cell, for example, for an elder person or some cognitive impaired person, would look like a zero, like there's almost nothing there for a more experienced person. But still is settled, at least currently, on 3%. So basically, if we have 3% of white pixels in a cell, then we consider it to be 1. And we are still working on this automatic tuning of the parameters and linking them to target user groups. So, and then after we've done that, we recover the original image. And the good thing is that now we can just send hundreds of images to the algorithm in a batch mode. It would be just processing each one of them and just providing the result, and we can use the output for some research. So we have a grid, and we recovered the original image, and we have zeros and ones. For example, here it would look something like that. An illustration of how the parameters can affect the grid, for example. So here in the left side, you can see the navigation is arranged with too many rows, with too many ones. And semantically, it's basically the same cell, right? So it's the navigation. So we can adjust the parameters, for example, this one, set it to 3. And then we can get a more kind of semantically logical distribution. Same here. That's kind of intranet of our university. We have probably too many columns and rows. So by adjusting the parameters, we can get more, I think, like reverse engineered structure. So that's what designer intended. So then the validation part. As I said, we used almost 500 screenshots of university websites. We automatically collected them from the web, and then we kind of discarded the ones that did not load automatically well, like that had some broken images or some, I don't know, automated warnings like accept cookies or everything. So that's why the number is not exactly 500. And then we had 70 subjects, participants in the experiment, mostly students of our university, but also some people working in IT. We wanted to collect their subjective assessments of complexity, aesthetics, and orderliness. That were the dependent variable. The Likert scale was from 1 to 7. And then the independent variables were produced by our algorithm. So we had the number of columns, the number of rows, the number of cells. And also, we introduced kind of a derived independent variable white space. That's the percentage, basically the percentage of zeros that we have among the total number of our cells. And so then we had more than 4,000 full evaluations, each for the 3 scales of complexity, aesthetics, and orderliness. So we averaged for each screenshot. And then we used linear regression, pretty simple method, because we just wanted to know if it's meaningful or not. We wanted to select the significant factors and use the backwards variable selection method. So what we got was, well, can be summarized in this table. It's also in the paper. So what's interesting is that white space was significant for all the dependent variables, which I think is reasonable, because as every designer knows, that white space is the most powerful, probably, factor that can be adjusted if you want to influence visual perception. And also, although R squares were not very high, especially for complexity where just one factor was significant, the regression equations for all the three dependent variables were highly significant. So that could not happen by chance, and we conclude that our algorithm do produce some meaningful results. And you might remember that for the manual overlaying of the grid, we had R squares something like 0.3, so a bit higher, but there we had just about 20 websites, so that's much less. So here, explaining this percentage of variability by something that we get from an automated software, I think is not that bad. So coming to the conclusions. First of all, I hope that I managed to persuade you that UI testing and analysis is at least as important as just software code analysis and testing. And there are two main approaches. One is more traditional one, fast and accurate, and it's widely used already, but still it has some limitations. So we are working in the field of image-based UI analysis, which is slower and less sure and has some other disadvantages, but it can see what the user sees, which I think is a pretty important advantage. And in our previous work, we proposed a sort of squint test that removes details except the ones meaningful for the visual layout of web user interfaces. And in that work, we found that the factors that we get out of this, they can be pretty useful to predict visual complexity. So we wanted to automate that, and in the current work, we did that. And we now can overlay this kind of grids and kind of perform this reverse engineering to what the designers actually wanted the columns and rows to be. The implementation is based on the pretty standard functions of OpenCV library, and we are still working on the parameters that the algorithm uses, because they, as I demonstrated, can affect the outcome pretty much. And also we want to adjust these parameters automatically depending on the category of target users that we want to access the perception for. So I think this is it. Thank you for your attention, and if you have any questions, please go ahead.
Thank you very much. Yes, we have some questions from Muhammad Panali. He said, thank you for your nice talk. And what are the possible techniques deployable to improve the features of images in machine learning approaches?
Well, I think machine learning approaches is too broad, because it depends what kind of images you are dealing with. For instance, if you want to recognize, I don't know, cats in general images, you can use image augmentation. You can turn this cat upside down, and you want your algorithm to still think that it's a cat. But for user interfaces, for instance, this is not that much useful, because if you turn your UI on a side like 90 degrees, then it's not exactly the same. For example, the button is usually never vertical, right? So it's horizontal. So it depends actually what exactly you mean by machine learning approaches. And we did not use any special augmentation here or anything like that. And basically, I told you about the steps of the algorithm, and I cannot say that it's really machine learning. I mean, we do not have any trained detectors yet. We want to use the machine learning techniques for adjusting the parameters. So basically, we want to train the algorithm so that it knows what should the parameters be. But so far it was not implemented, so I do not think that I can tell about much machine learning in the current paper.
Thank you. And next question: what are the signal modulation and demodulation techniques generally used in such work?
I'm sorry, I don't quite understand that. What's a signal here? You mean the image again?
Modulation.
Well, I think I told you. Well, maybe you could clarify what exactly the techniques and what is such work. We perform transformation of images. I don't think we relied on modulation and demodulation.
So maybe we can continue the discussion in our Telegram chat and clarify these moments. Yes, so we have a link to our Telegram chat. Please use it for discussion, because now we have this is a comment: signal processing techniques for using image extraction.
But image extraction from where? I mean, to obtain the images, we used the headless browser, which would curate the address, and then we would make the screenshot. And again, in this work, we did not extract any elements from the images. If you want, there is the service that we have. I mentioned it. There, actually, we do perform extraction of elements from the images. I just briefly shown that, but that's not exactly related to the current talk. So I think if you're interested, you can just take a look at it and maybe email me.
Okay, thank you. Thank you, Maxim.
Thank you very much.
Yes. Now we should continue because we have less time. Let me introduce our next speaker, Anastasia Kaida, teaching assistant at Tomsk Polytechnic University. Hello, Anastasia.
Good evening.
Good evening in Tomsk.
Quite some time.
Good afternoon in Moscow. Okay, so are you ready?
Yeah.
Yeah. Okay, let's start.
Okay. I think today I'm going to tell about modern experiment management systems architecture for scientific big data. This is a topic of several researches I took part because before I worked at CERN, and also I have some researches in our laboratory of unstructured data processing. So we decided, I'm a PhD student, and I've decided that I'd like to collect all my experience for my PhD work. And this is a starting point, and I'd like to tell more about modern scientific experiments. What is a major problem of all the experiments? When we are talking about modern scientific experiments, we usually talk about different data and heterogeneous infrastructure of these experiments. And when we are talking about data, also we consider that there are a lot of different sources of data. It can be manually created data. It can be data gathered from different devices. It also can be data produced by any other software. And usually when we are talking about old-fashioned experiments, there can be just data that created manually, but usually when we are talking about different spheres of experiments related to some hardware and software, there are different points of collecting data that we need to aggregate and to process it somehow, because when we have several tries, especially in some experiments with some modeling and simulations, we we need to control this process from time to time just to understand how to collect this data. Because usually experiment digital environment that exists can grow in an unpredictable way. We understand it by our experiments in our research group, because when we are talking about research teams and research team aims and objectives, we understand that we we may change our goals after several iterations of our experiment, especially, for example, in some experiments related to, for example, data processing itself. I mean, for example, text processing and something like a text recognition or other different kind of experiments related to maybe social science or other kind of sciences, when we have one hypothesis and we reject it and we need to restructure our experiment, the whole of our experiment. Also, at the same time, we need to build a stable and flexible data flow, because on the one hand, we need to, when we are talking about modern experiments, we suppose data stream processing. On the other hand, when we change our goals and aims, we need to rebuild as soon as possible with a low cost the data flow, the whole data flow, and it's better not to create something like a standalone module that do everything at once, because in this way we can collide with some big problems, and we can lose a lot of time for reprocess this experiment. And the problem also is that different research teams and different experiments have different styles and different patterns. But actually now in literature we can find the same issues for modern projects with different solutions. And when we collided with some issues in our laboratory, I mean at TPU, we understand that it's better to find a unified pattern. And when we are talking about unifying pattern, it's about style and about some maybe some software that we can develop, but usually when we are deploying something, we also can look at as a background. So the pattern means not that we need to implement everything at once in some unified way. And also one of the biggest problems in modern experiments is the exponential growth of data. And it means that we are not able to gather everything at once and without any supposing that something can be like the things that we need to get rid of. Because, for example, when we are collecting some data from web, we understand that it's like a limitless source, and we cannot gather everything because, for example, sometimes we even need just a small data snapshot, and that's it. For this pattern, that's enough. And also, when we are talking about scientific experiments, we can say that expansion of cooperation through the creation of scientific collaborations also can give us some impact, because, for example, an experiment can start from a small group of researchers and from 1 or 2 or 3 iterations and one experiment, but then this laboratory can, we can imagine one laboratory. This laboratory can involve several research teams from other, let's say, universities or some research institutes. And we also have the fact that an environment can be expanded, and then we have an exponential growth of data and many things around. So one of the projects that I took part in, it was related to high energy nuclear physics experiment Atlas, where you know that This is one of the biggest laboratories in the world related to this field of study. And Atlas is the biggest detector at CERN. So, of course, there are a lot of different research groups, but when we were talking about metadata, so data about data of research experiments, there are two huge information infrastructure here because Atlas experiment has a long period of existence. And we understand that there are already a lot of different sources and subsystems that keep some information about experiments, but it's still a really big deal for scientists to find some information in different separated storages about the one experiment, and when they need to reprocess something and to recall something, it takes a lot of time and have a lot of issues. That's why we decided to create data knowledge base in collaboration of TPU, CERN, and Kurchatov Institute. And this is a great experience, but when we were describing and developing different parts of this system, we didn't consider this like an experiment management system, but when I decided to look back, what was the origin of this topic? Actually, our data knowledge base and the subsystem of metadata management has all features of experiment management system, and the origin of such kind of systems were even before so-called digital age, and of course the age of big data, which I will talk about later. And Zoo experiment management system was one of the first systems. This system was some kind of desktop systems, and through the time we found several different examples of different systems. The major part of them has the aim of the major part of those systems were not about creating unified pattern or creating something like lightweight to manage. It was something like a really huge subsystems with or orientated on a particular subject. That's why it was all the systems have their own features, which we considered, and we gathered the pattern across the experience of different research teams, and we tried to understand what were the key features for all of the systems, and we decided to add what we gathered to our concept. And what about big data ecosystem? Actually, of course, for example, Zoo system was created before big data ecosystems, but now when we are talking about data acquisition, data aggregation, and data storaging, all of those questions are about big data today. And it means that usually we need data integration subsystems just in case, because we are not able to gather everything at once and process it. And we need to deal with data streams, and we need to decide what we need to keep and what we need to reuse somehow. And also we are working with heterogeneous data sources, because this is also a key feature of big data, because big data related to a variety of different data types. And this is also an issue for processing. And also, when we are talking about experiment and about big data, we understand that we need the whole data lifecycle support. The data lifecycle starts from gathering data from a particular source, or from the moment when data is created, maybe by our subsystems, it doesn't matter, and till the moment when the data will be kept in a in a storage, or it can be reduced also. So data should be observed during the life cycle, and data management is one of the tasks inside such kind of systems. And also there is another problem why we cannot provide just simple engineering solution. It's just because we have an unknown data value before exploratory data analysis. So we understand that we can change the data source because of changing the goals and aims of the research group, or we can add another source, and at the same time we still don't know what's the value of this data, and we need to create some data snapshots and add some snapshot storages, for example, till the moment when we will understand what is the value of this data, and something like this. And also, when we are talking about data, of course, we understand that in this ecosystem we still have the problem of rapid growth of data, and it should be managed by any kind of different software. Turning back to the research, the previous researches, I'd like to describe briefly about Atlas DKB. On this slide, you can see the data processing pipeline. The thing is that we apply such kind of architecture because of usually we depends on our architecture depends on the decision of physicists, and that means that our data pipeline could be changed by their decision at any moment. And when we are talking about development of different data processing pipelines, it's better to use ETL concept. When we have on each processing stage, we have just one atomic operation for one module, and in that way, it's this is the easiest way to process data. At the same time, it still takes time. That's why we decided to use such kind of technique. And when we were talking about how it should be in our future test bed here at TPU, we decided that we still use ETL pipelines because this is a good technique for, let's say, so dependable data processing needs. On the other hand, we still have research background at TPU in our laboratory of unstructured data processing, where we have the tasks about web mining and opinion mining. And it means that usually we process different snapshots of texts gathered from open sources. And we have flexible workflow because we usually have different tasks, and those tasks are divided through the research team. So we have also multi-branch working process, and this process have some, let's say, issues because different researchers have different styles and different qualifications, because this is an interdisciplinary research team. And at the same time, we understand that there is a need of experiment cataloging, and that's why we still need to manage this process and to organize this process as easy as it possible, because some researchers, they have they have just average skills of programming, but they have, for example, some skills in other disciplines. That's why we need to provide also some kind of interface and some kind of simplified tools just to interact with input and output data interfaces. And what about our concept? Our concept is to develop a unified pattern based on several components that are presented here. It's about metadata management system, protocol for metadata management system, ETL pipelines, knowledge base, internal and external heterogeneous data sources, and message-oriented middleware. Those components are required for building such kind of system. I'd like not to say in this presentation about the details of such kind of software, but a part of software as ready to use is open source software, for example, message-oriented middleware. But when we are talking about ETL pipelines and protocol for metadata management systems, this is our experience that we implemented by ourselves. And the main research is performed based on the Laboratory of Unstructured Data Processing at TPU. So we decided to try to make a test bed. On this slide, you can see the principal architecture of this test bed, which we are gonna to deploy this spring, I think, with several heterogeneous storages. But on this slide, you can see that this is a high-level architecture. We consider that we don't know how many pipelines and data sources we will involve, because it can be changed by a decision of a research team, for example. And for our future plans, I think this is the shortest part. It's about building a workflow. We are gonna to build a workflow for the laboratory and to make a test bed for the lab projects. And also we are planning to test and deploy the initial implementation of the full system based on our experiments of the both laboratory working parts. So that's it. If you have any questions.
Anastasia, thank you very much for your presentation. Let me check if we have some questions. For now, we have no questions. So but we have Telegram chat. Okay. We can discuss some interesting things there. And thank you very much. See you at our university. Yeah, we have one question. Okay. Do you use any computational methods to hand in data?
Can I see the question? Okay. What kind of handling is supposed? Because it can be divided at least to 3 tasks: data extraction, data transformation, and data storaging. So what is supposed under this question?
We have a little delay in time. Furkan Ali asked this question. Maybe he can comment.
I can generally ask. I think it can be enough, because as I told before, we use an ETL pipelines just to control and to make it flexible, and at the same time we'd like to use all together with those like pipeline models, message-oriented middleware, and in this way we can control the data flow.
Thank you. Thank you. So we can continue our discussion in our chat. Telegram chat, and now also YouTube chat. So now let me continue with the next speaker, Ilya Samonenko.
Hello.
Hello. Hello. Ilya Samonenko, Associate Professor at Higher School of Economics. So
Well, yes. So, hello, my name is Lian, and also I'm Deputy Dean of the Computer Science Faculty of the Higher School of Economics. So, my report on the topic and approach to modular similarity definition based on the system log analysis. The purpose of our work is to construct a distant function between models based on our partial knowledge that some models have similar behavior. Okay. Suppose we have several modules M1, Mn, and several tokens T1, Tr. Tokens go through the system and is processed by some modules, at least one. When token Tg is processed by module Mi, it generates one of the possible outcomes, or one OK. So we have a function sigma from modules cross tokens to outcomes or undefined element. We call it a digital mark. If token T is missing in the module M, then sigma of M and T is equals to undef. And now we can define a digital trace of the module M as a vector of all digital marks by all tokens. And a log of modular system is a vector of all digital traces by all modules. To be able to compare digital traces, we must assume that there is a distance function on the outcomes. But for simplicity, we will assume that the outcomes are integers from 0 to k. And let S is some fixed natural number. And we say that two modules, M1 and M2, are comparable if there exist at least S tokens for which the both sigma of TM1 and sigma of TM2 are defined. For example, for S equals to 3, if digital trace of M1 like this one, and trace of digital the digital trace of M2 like this one, then M1 and M2 are comparable. Further, we will consider only comparable pairs of modules. There is the main problem of our research. Suppose that we know that some comparable pairs M1 and M2 are similar. In some sense, in the following, I will give a concrete example of similarity. And let pi is the set of all comparable pairs M1, M2, for which we know that they are similar. I will make two remarks. The first one, if M1, M2 not in pi, then we don't know anything about M1 and M2. They may be similar or not. And the second one, the cardinality of pi might be much smaller than the number of all comparable pairs of models. Thus, only for some pairs in M cross M, we know that they are similar. And we don't know anything about most of pairs in M cross M. And our goal is to define some distance function d on M that respects similarity. It means that for all M1, M2, M3, M4, if M1, M2, n in pi and M3, M4 not in pi, then d of M1, M2 is less or equal to d of M3, M4. If the models are similar, then they should be close to each other than other pairs of models. If such function doesn't exist, our goal to find the best approximation. Why do we solve such a problem? To determine abnormal behavior. We can do clustering models using the distance function. Suppose we know that all red models are similar and therefore they must be close to each other, and also that all blue models are similar and therefore they must be close to each other too. But suddenly we get that one of the blue model is far from its cluster, and this is the reason to check what has happened to it. We will build a new distance function based on standard distance functions and standard correlation functions using digital marks for identical tokens. For example, it can be L1, L2 distance, Hamming distance, different correlation coefficients like Pearson, Spearman, Kendall, and so etc. And the list of such functions depends on the properties of our system. It can be big, and you can add any functions that have some sense for your system. But it's important that those functions should be normalized, and their maximum and minimum values should not depend on the number of identical tokens. Therefore, we have a coefficient here, 1 divided by n, where n is a number of identical tokens. For example, if traces of model M1 and M2 have 3 identical tokens, then we calculate L1 distance in such a way. And if the models M2 and 3 have 4 identical tokens, then we use another n in this formula. So we have the following data. All comparable pairs, all pairs of comparable models, and we can find the values of standard distance functions and correlation coefficients, and also we know that some models are similar. And now we use some simple machine learning techniques to solve our problem. So our objects are pairs of all comparable models. Our features are the values of standard distance and function and correlation coefficients. And the target value is one of 2 classes, similar or not similar. So we must to train positive undefined classifier with 2 classes, similar or not similar. I note that we have exactly positive undefined classification, but not positive negative classification, because we have only objects that belong to the first class similar, and there are no objects that belong to the second class not similar. At the same time, we can calculate probability P of MIMG, that pair MIMG belongs to the class similar. And after that, we can define function D that equals 1 minus P. Of course, we have no guarantees that the function D is a metric, and we have to check, we must check this property, and it's necessary to find the proportion of those triples for which the triangle rule is true to all triples of pairwise comparable models. And if the value here of D is small, then we need to change something in our functions or correlation, or change something in our classifier and a description how to correct the situation if the value here of D is smaller is the goal of our future work. But now I want to talk about the application of our model, and in this case, here D was good. So we applied our model to disciplines and students of the Higher School of Economics. Models are all disciplines of all educational programs of the HC in the period of 2017 to 2020, and we have more than 15,000 of disciplines. Tokens are students, and outcomes are the grades of the students in disciplines. Grade scale from 0 to 10, and we have over 2.5 million grades. And the digital trace of discipline is the all grades of the students. We say that disciplines are comparable if at least 10 of same students passed exam on in these disciplines. And we have around 1 million comparable disciplines, comparable pairs of disciplines. And what did we mean by similarity? Disciplines M1 and M2 are similar if the first, they have the same name, and the second, they was implemented in the same program, in the same academic year, and the same astronomic year. For example, for bachelor's program Applied Mathematics in Information Science, disciplines calculus in fall semester and in spring semester are two different but similar disciplines. And we train our positive undefined classifier with rho KAUP equals to 0.81 and the HOD equals to 98. It's very important. This means that the function is almost always a distance function. Finally, I want to show you one picture. This is a two-dimensional representation of disciplines based on distance D. Let's look at this. For example, 10, 11, and 1. 10, 11, linear algebra and geometry, and 1 is algebra. They have different names, but they know that we have similar content. And our matrix indicates this, and we see the cluster, linear algebra, algebra, and calculus. And other cluster, 2, 3, 15, algorithm and data structure, and introduction to programming. It's obvious one cluster, but this is 14, introduction to programming, is far from this cluster, and this is exactly abnormal behavior. And this is a reason for academic supervisor to pay attention to this. Why did this happen? Thus, this approach helps academics supervisor to analyze the grade system of the educational program. So that's all. Thank you. Any questions?
Thank you, Ilya. For now, we have no questions. But as I said, we have a little delay in time with YouTube channel. So thank you again for your presentation. And please also take a part in our third day of conference. Please engage in the discussions and ask questions. So we have no time to wait for questions, but we have a Telegram chat. Please use it for discussion. So now I have to say goodbye. Thank you very much for your good job for today. Very interesting presentations. So many questions and discussions. And I hope that everyone will join us tomorrow for the last day of the conference. And see you tomorrow. Bye. Goodbye.